So good afternoon everyone, you all mechanical warrior. Just before starting the session, let me know, is everything fine or not? Audio, video both are clear or not? And today we are going to start a very important session for all the mechanical engineer. Just उससे पहले आप मुझे ये बता दीजिए, is everything fine or not? क्या audio, video clear है? And after that we are going to start a very important session, my dear. Yes. Okay. So just do like. Okay, audio, video both are clear, just like the session. Yes, okay, both are clear. So today we are going to start a Maha Marathon for the entire thermodynamic. In this 2-3 hour of session, we are going to cover each and every formula, each and every single point of the thermodynamic. So first join the session, and till now if you have not joined, jaldi se aap share kar do session ko. Share the session you all, and after that we are going to start the today's session. Yes. So are you ready guys? Can we start? And after that, if you will just download this PDF or I'll share this PDF in the group, या फिर आप as it is. Yes, I'll continue everything in English, don't worry. So after the complete annotation of this PPT, if you will download or if you will get from my Telegram channel, then you need not to make any separate short notes. ये आपका till the exam it will be more than sufficient. Okay, so just write in the comment section, is everything fine? Yes sir, everything fine. Okay, so there are very few of you student, so let's start the session. Yes, myself Sonu Chauhan, I welcome all of you on BYJU'S Exam Prep, India's most comprehensive learning app. If I'll talk about myself, then this is all about me. I have 10 years of experience in teaching field of GATE and ESE, MTech in thermal. And if I'll talk about these all the written exam, I have qualified the GATE examination 4 times ISRO, as a scientist 2 times, NPCL, and after that GPSC class 2 officer and railway, my dear. Okay, and right now we are going to deal with this particular subject, that is the thermal. Great. Okay. So before starting the session, let me tell you some important point. Again, I welcome you, and if you are the new on the channel, my dear, if you all are new on the channel, then do join the channel, subscribe the channel, क्योंकि daily आपको update यहाँ पे मिलते रहती हैं. Number of time you just feel the number of session like this. Okay, great. So be calm, थोड़ा सा patience रखो. The reason, let me tell you, that we are going to discuss each and every concept of thermodynamic in next 2-3 hours. So again, time बहुत लंबा है आपका. So be calm, and just this is all about the topper of BYJU'S Exam Prep. And always I say, अगर ये PPT या ये slide आपको इंस्पायर नहीं कर पाई ना, then there is nothing in the entire universe जो आपको इंस्पायर कर दे. Because if you don't have the dream to be here next year 23, then I think there is no mean to dream anything, especially for the GATE exam. Sir, first of all, before starting the session, let me know how many of you have dream in your eyes, in your heart, that sir, next year there must be one photo of mine on this frame. Just write in the comment section, and next we are going to start the session, my dear. Write down fast. Yes, good afternoon, you all mechanical engineers, you all mechanical warrior, good afternoon. Just write in the comment section, how many of you have same dream, sir, next year we will be on this frame, and after that we will start the session. Great. Yes, Naga, good afternoon. Raj, good afternoon. Okay, my dear. So, sir, if you have the fair notes, it is okay. If you don't have the fair notes, I'll just, a maximum of the thing I have just written in this PPT. And after that, what exactly you need to do, something I will mention each and everything. And it will be completely in the form of PPT, completely in the form of short notes, my dear. Correct. So this will be very useful when you have already attended or you are already aware with the basic concept of the thermodynamic. Great. Okay. Under 100 rank, Naga. Good. Very good. So let's start the topic, my dear, and one by one for next 10 to 5 minutes, you can feel that, sir, these points we know. but just for 5 to 10 minutes, let's try to understand all the basic concept of the thermodynamic, and just after that drive each and every formula. Okay. Sir, can you share the session in group because number of your engineers are very okay. Less. Sir, if you have not joined the Telegram channel, join the Telegram channel, because after that I'll share the entire PDF. And let me clear, after completion of the session I'll share the complete पैकेज विद यू ऑन द टेलीग्राम चैनल. इस मैकेनिकल वाई सोनू चौहान पे आपको कंप्लीट पैकेज मिल जाएगा. कैसे? देयर इज नो कॉस्ट ऑफ दैट वन. I'll share all the formula, all the important point, what exactly we are going to discuss with these entire PDF or PPT. I'll share the question of these chapter by PPT or chapter by previous year question approximate 2000 to 2021 तक आपको क्वेश्चन भी चैप्टर्स के साथ ही मिल जाएंगे आफ्टर द लेक्चर. ओके, ग्रेट. सो लेट्स स्टार्ट द सेशन माय डियर. Okay, so we are going to complete our thermodynamic in this complete way, my dear. First of all, we will start with the basic thermodynamic. After that, or basic concept of the thermodynamic. After that, first law of thermodynamic, second law of thermodynamic and entropy. Finally, available energy, availability and irreversibility. And at last, we will discuss thermodynamic relation and pure substance, my dear. So without wasting time, let's start the topic. That is thermodynamic chapter number 1. What is chapter number 1? What is the basic concept of thermodynamics? Sir, each and every point, each and every formula, whatever we are going to discuss, each and everything must be on your class notes, short notes or rough notes. Okay. Basic concept of thermodynamics we are going to discuss here. This is the first chapter, my dear. Okay. Sir, if I'll talk about this, what is the thermodynamic? Then it is simply the branch of science which deal with study of energy conversion and its effect on the physical property of the substance, all I'll write system. So ultimately your purpose is to convert the energy, either it will be the heat or work, into the some other form of energy, and then you will check what is the effect of these all the property on the substance or the system. And ultimate aim is to convert inorganized form of energy, that is heat, into organized form of energy, that is work, in efficient manner, my dear. So in this case, if I'll talk about this heat, then this heat I'll write inorganized form of energy. Inorganized form of energy. And you can ask why it is form of energy. Why? Because when you will supply heat to any particular system, then definitely randomness or molecule will move in the inorganized manner. And if I'll talk about the work क्या हो जाएगा? Yes, it is organized form of energy. It will be organized form of energy. How? When you will supply work to any thermodynamic system, then all the molecule will try to move in organized or sequential manner. Okay. Second, sir, second point, what is the difference between the thermodynamic and heat transfer? What is the major difference between the thermodynamic and heat transfer? These all short notes we are making here. Sir, thermodynamic deal with energy conversion. When work will be converted into heat or heat will be converted into the work, then at that time I'll say yes, it is a study of thermodynamic. And when it will be a topic of heat transfer, then it is the study of transfer of energy from one particular point to second particular point. Make your all the short notes in the same way. So when I'll talk about the thermodynamic, it is the energy conversion, heat into work, work into heat, enthalpy into the mechanical work, chemical energy into the mechanical work. At all the points we will discuss the thermodynamic. But when it is the transfer of energy from one point to another point, then it is nothing but it is the study of HMT, my dear. Okay, first point, let me clear. Is this point clear to everyone? For example, in this case of compressor, my dear, this, let me tell you this example 1 to 2, if it is the pump. So in this case, my dear, your work is converted into the enthalpy. So only 1 to 2 I'll study in the topic of thermodynamic. But when it is the transfer of heat from one particular point to second particular point, or in the pipeline, that is nothing but that is the portion of heat transfer from one particular point to second particular point. That is the study of heat transfer. Sir, is it clear to everyone? Just write in the comment section. Is it clear to everyone? First. Okay. Great. Second, if I'll talk about the thermodynamic, then yes, a system or all the property you will measure from a thermodynamic system when it is in thermodynamic equilibrium. Sir, what is thermodynamic equilibrium? It must be in mechanical equilibrium. It means no unbalanced force is applied on the system. No unbalanced force apply on the system. No temperature or throughout temperature is same within the system. Within the system. And again, if I'll talk about chemical equilibrium, then yes, no chemical reaction must be there. No chemical reaction must be there. Yes. Okay. Great, Vanu. Yes, Kumar. Very good. After that, so till now we have discussed 3 equilibrium, that is one mechanical equilibrium, second thermal equilibrium, and third one is the chemical equilibrium. Because we have already studied that entirely my thermodynamic property will be measured when equilibrium will be maintained. Great. After that, we always study the microscopic approach. Sir, what is the microscopic approach and microscopic and macroscopic approach? We always study the macroscopic approach. So in the microscopic approach, if a certain quantity of the matter is considered by event occurring at the molecular level, when you are checking the behavior of each and every molecule, and after that with the help of some statistical method, you are going to finalize the property. That study of the thermodynamic is known as microscopic approach, and that thermodynamic is known as statistical thermodynamic. But again, in applied thermodynamic or in our advanced thermodynamic, we always, yes, Raja, we always study the macroscopic approach. Means a certain amount of gas, certain amount of molecules is considered as a single identity, and then you check what is the behavior of this entire identity. So in this macroscopic approach, you never go with the molecular level. You always check, my dear, you always check the entire group of the molecules as a single identity, and then you always talk about the property change of this identity. Okay. So for example, if it is a thermodynamic system like this, so you will never check all the molecule. All the molecule you are not going to check in thermal. What exactly you all will do? Sir, in this case we check this total group of molecule as a single identity, and I'll say this as a system, my dear. This as a system. So there is a big difference between the microscopic and macroscopic approach. In microscopic approach, each and every behavior of the individual molecule you check, but in macroscopic, number of group of molecule are considered as a single identity, and you check the behavior of that identity or the system. Clear? Great, great, great. Okay, good. Yes. So can you write where microscopic approach you will apply? Where microscopic approach you will apply? Any one of you? Any one of you can write in the comment section. Yes. Okay. Sir, at very high altitude, number of molecules are very less, and concept of continuum fail. So yes, at very high altitude you can apply the concept of microscopic approach. Even in rarefied gases. In rarefied gases, my dear. Gases, you can apply the concept of microscopic approach. But when you will talk about the dynamic, thermodynamic, sorry, not dynamic, it is a classical thermodynamic, sorry. It is classical thermodynamic. So again, in the entire thermodynamic, we are going to use this one, that is the classical thermodynamic. But again, you must know, my dear, where we are going to use this classical thermodynamic and where we are going to use this microscopic. It is a simple fundamental, number of molecules are less. I will always go with microscopic approach. Concept of continuum will fail in the rarefied gases. Yes, let me make one more star point. Concept of continuum. Write the star point. Continuum fail in rarefied gases. Okay, rarefied gases. Great. Absolutely right. Yes, it's a very good example in space application or in rarefied gases. Great. Next, system. Because in the last lecture we have in the previous slide we have discussed, my dear, very important point, that thermodynamic is nothing but it is the energy conversion and its effect on the property of the system. So you must define what is the system. For example, if I am dealing or if I am going to check the behavior of this entire molecules or gas within the boundary, then before starting the thermodynamic I must define the system, my dear. Because when you will change your system, number of things will change, my dear. So yes, you must define the system, you must define the surrounding, you must define the universe. So in this case, if this one at any time, my dear, if this one is a system on which your study is completely concentrated, then this one is a surrounding. And this complete combination, my dear, it will be nothing but universe will be equal to, these are very simple points we are writing here, but after that your pure study after 10 to 5 minutes will be started. System plus surrounding. But again, few star point we must write. Surrounding, that is the system plus surrounding will be nothing but it will be a universe, my dear. After that, I'll share this entire PDF or PPT so that each and every point how we have derived, how we have written in the star form, so that you will get the idea, and in each slide you get only one formula. So it will be, I think, good for your practice. Sir, if I'll talk about system, we have already defined any quantity of matter or region in the space is nothing but system, already defined. Surrounding, anything external to the system, surrounding or environment, and universe, combination of both is universe. Let me make one important point, my dear, boundary. Very important point, boundary. It's a star point. From the previous slide I can check that boundary is nothing but it's a separation line. It is a separation line between system and surrounding. So can I write? It may be rigid like room. It may be rigid or flexible like balloon. Flexible, my dear. May be visible, or I'll say real, or imaginary. Yes, your boundary may be rigid or flexible, your boundary may be visible, or you can say real or imaginary. Great. ये बहुत basic point है, अभी हम discuss कर रहे हैं. Yes. After that, if you will talk about the system, then there are the three, already we are going to define system. There are three type of system. In closed system, Mass will cross the boundary? No. But energy will cross the boundary? Yes. Energy will cross the boundary? Yes. Can you write the example, my dear? Example is nothing but piston cylinder arrangement without valve. Cylinder without valve. Without valve. Sir, open system? Mass will transfer? Yes. Energy will transfer? Yes. Example, my dear. Can any one of you write the example? Yes. All maximum number of practical example are the example of open system. That is compressor, turbine, boiler. Maximum of thermodynamic example are related to the open system, because when you will make this difference from the starting, then you will come to know कि सर कहां पे कौन सा फॉर्मूला अप्लाई करना है. अभी देख के आपको लग सकता है कि सर बहुत बेसिक चीजें चल रही है. यस, नेक्स्ट 10 to 15 मिनट बहुत ही बेसिक चीजें चलेंगी, बट आफ्टर 10 to 15 मिनट व्हेन वी विल कम ऑन द मेन पार्ट, that will be from the zeroth law, work done, different process, formula of the work done for open system, for closed system. When I will give you the number of table, then you will feel at that time कि ये सारे basic concept जरूरी हैं, right? Isolated system, mass not transfer to the system, energy will also not transfer to the system or not cross from the boundary of the system. So if I'll talk about the example, anyone? Insulated flask. Flask is one example. If I'll talk about the second example, okay, thermoflask is the one example. And if I'll talk about the second example, it is universe. This is the universe. So if you want to check all the important point I have written here, आप यहां से अच्छे से चेक कर सकते हो कि क्लोज सिस्टम में मास विल नॉट ट्रांसफर, एनर्जी विल ट्रांसफर, एंड एग्जांपल पिस्टन सिलेंडर विदाउट valve. If you will talk about the open system, then in the example of open system, you can feel that mass will transfer, but energy will not transfer. Mass and energy both will transfer, but in the isolated system, my dear, neither mass is transferring from the system, not energy transferring from the system. Example are given to you. Okay. When next point in second chapter or third chapter will be discussed, then you must know it is the example of open or closed system. उसके बाद सारे law apply करना, apply all the laws after that. Okay, great. Sir, now after that, what is the thermodynamic property? Because if you will just remind the previous lecture, then you will feel a very important point, that thermodynamic is the study of energy conversion and its effect on the property of the system. Sir, you have studied everything about the property you have studied everything about the system. My dear, अब आपको खेल करना है. You have to study the property and then you convert the energy. If you will just focus on the first line of the thermodynamic, and not only the thermodynamic, for any particular subject, then you are not going to worry about the entire subject. You need not to worry about the entire subject. आपको सिर्फ पहली लाइन को पकड़ना है. This is the energy conversion and its effect on the property of the system. System study. 3 type of system are possible in my thermodynamic study. Now come to the second point, effect on the property of the system. Come to second point, property of the system. So first of all, let's try to know what is the property of the system, Karthik, and after that we will discuss how many type of property are possible, how they will change. So yes, property of system is nothing but any measurable characteristic of a system that depend upon the state or condition of the system. If the condition of the system is going to change, then yes, thermodynamic property may change, my dear. If we'll talk about the extensive and intensive property, then extensive property, my dear, dependent upon the size. Depends on size or mass of the system. And this one, my dear, independent from mass or size of the system. नंबर ऑफ टाइम इसमें कोई नया पॉइंट नहीं है, आप बार बार कहोगे सर ये बहुत बार हमने पढ़ा है. नंबर ऑफ टाइम वी हैव स्टडी दिस पॉइंट, देन व्हाई वी आर गोइंग टू राइट दिस स्टार पॉइंट? क्यों इसको बार बार लिख रहे हैं सर? व्हाट एग्जैक्टली और हाउ एग्जैक्टली यू विल चेक दिस प्रॉपर्टीज इंटेंसिव और एक्सटेंसिव? whenever any quantity is given to you, you will take 1 kg of that quantity, you will take 2 kg of that quantity, you will take 10 kg of that quantity. If that particular property is changing, it is the example of extensive, and if it is not changing, example of intensive. Simply, if I'll talk about density, then there is a very important question must be there in your mind. Sir, what is the density of water? 1000. 1 kg water, 2 kg, 1000, 10 kg, 1000. It means it is independent from the mass. Now after that, if I'll talk about the specific heat, think what is the specific heat of 1 kg of water? 4.18. 2 kg of water, 4.18. 10 kg of water, 4. It means again it is independent from mass. Check the thermal conductivity. So in this way, when you will apply all these concepts in ESC exam, if you are going to write, in PSU exam if you are going to write, this point is going to be a very helpful for you guys. Okay, बहुत आसान होने वाला है आपके लिए. Yes. After that, how will you check? This is a very simple way. Sir, you will divide your complete system into 2 parts. This one, and divide your part into 2. So in this case, if mass and volume is divided, yes, it is extensive property, my dear. This one is the extensive property. Check the mass. And this one is the intensive property. Intensive property. Sir, after that, yes, it is everything. Whatever you have written in the comment section, yes, everything fine. But again, story does not end here. आपके माइंड में नेक्स्ट क्वेश्चन ये आएगा, कुछ ऐसे स्टार पॉइंट हमको मिलने चाहिए, so that simply just by watching that particular option, by getting that particular option, we will get in mind कि sir, this is the extensive property, this is the intensive property, like this. So let me give you 3-4 star point for a property. Yes, first, most important, or I'll say key point regarding the intensive and extensive property, my dear. Intensive and extensive property. All the form of energy are extensive property other than work and heat. These are also the form of energy, but these two are not the form of energy. All the specific properties are intensive property. When you will just add a simple word before any property, that will automatically become intensive property. Sir, specific enthalpy, intensive. Specific entropy, intensive. Specific volume, all specific properties are intensive property. And last, ratio of two property is the intensive property. Density is the mass of two extensive. Ratio of two extensive property. Example is the intensive property. Great. Intensive property, my dear. Good. Very good. All of you. Sir, till now, are you completing your short notes also? Because my purpose to conduct this class or this session is only one, because after that, related to thermodynamics, you will get everything in this session. You need to do the practice more and more after that. Whatever we are writing is everything clear, my dear. अभी तक सब कुछ समझ आ रहा है? ऐसे समझने का तो नहीं है, it's a complete revision, right? Yes. And I think this PPT is going to be a more useful for all of you. Yes. Very good. Next. Yes. Sir. Very good. Thermodynamic state. Thermodynamic state. The condition of a system at any instant of time is a thermodynamic state. For example, I am checking, or I am going to check this property at this particular point, pressure P1, and this particular property, pressure or volume V1. So this is nothing but this is the thermodynamic state of the system when I am going to measure the thermodynamic property. And one thing is clear, if this state is not going to change, my dear, then property is not going to change. So yes, it is a stop point for you. As long as state is fixed, thermodynamic property will be fixed. It is never going to change. Yes. After that, it will moving from 1 to 2, my dear. Either like this, or like this, or like this. There are the number of pros path. So the change of property means change of pressure either in path A, my dear, and change in pressure either in path B, my dear, and change in pressure in path C, my dear. In all the path, my thermodynamic property is not going to change. So if I'll make some star point, few star point, very important star point related to the property and thermodynamic state, you will get very important relation from here, my dear. Very important relation. And that is key points regarding the state and properties. As long as your state is fixed, all properties are fixed. Correct. Properties or system are independent from the path. Because in the last lecture we have written, my dear, in the last slide, sorry, we have written change of pressure for A, change of pressure for B, and change of pressure for C. It will be same. It will be same. बिल्कुल सेम रहने वाला है, कहीं से कहीं तक चेंज नहीं हो रहा. Great. So that is the reason all the properties are only the function of initial and final point, and that is the reason properties are exact derivative. And last one, all properties are independent from the past history. These four important points are related to the state and property. If this point clear to all my mechanical warrior, then just write the answer in comment section, my dear. Yes, everything you will get in my Telegram channel, don't worry. I'll share the Telegram channel after that. You just write in the comment section, is everything clear to you or not? With the numericals you will get also. I'll share number of problem with you chapter wise. Yes, is everything fine? Yes. So it is known as point function. Great. Absolutely good. Very nice. And yes, it is just an information for all of you. If you all are definitely you all are the mechanical engineer, my dear. So tonight at 10 p.m. we have a session for all of you in which we will discuss entire complete strategy for next 200 days. So if you are again worried, if you are little bit tense, sir, what will be the proper strategy, what will be the planning, then you can join tonight at 10 p.m. on the same channel. That is the reason, if you have not subscribed the channel, then just do join the channel. And yaar, like to karo, like the session, my dear. Chaliye. Yes, thermodynamic process, sir. Already we have discussed that my all thermodynamic properties, my dear, will be checked in thermodynamic equilibrium state. So when you are in equilibrium state means that pressure is P1, volume is V1, and temperature is T1. Just for example, any property you can take. So when you will just remove this weight, then next equilibrium process or next equilibrium state will be maintained by the system. उसके बाद अगली equilibrium state आ जाएगी. And at that particular state, my dear, you will take other property. You will consider the next property, that pressure may be P2, volume may be V2, temperature may be T2. If I'll represent these all the process on, sorry, if I'll represent these all the process then I can draw my pressure and volume. It may change like this. Arbitrary diagram I have just drawn. There is the change in the pressure and change in the volume. So yes, change of one equilibrium state to second equilibrium state, my dear, is known as thermodynamic process, nothing else. So I'll write what is thermodynamic process. Change of a system, when its change is thermodynamic or equilibrium state, this is known as process, and process may be flow or non-flow process. What is the meaning of non-flow process? You are going to conduct the process in the closed system. What is the meaning of flow process? You are going to conduct the process in open system. Correct. Okay. But again, after that, there are two type of process, and most of the time we will consider that process which is not possible. That is reversible process, free, and it is most efficient process, my dear. Most efficient process. I'm not going to write the definition, नहीं तो ये पूरा आपका class notes बन जाएगा. Otherwise, this short notes will become the entire class notes. Okay, I'm not going to write all the definition. Most efficient process is the reversible process, and second, it is irreversible process. So again, friction is the main cause of irreversibility. Friction is the main cause, my dear, of irreversibility. Great. After that, so two process we have discussed: reversible process, irreversible process. After that, yes, one is quasi-static process. To make the process as a reversible process, we have conducted. Okay. Yes, Deepak, I think you join a little bit later, because in the starting we have defined what is the meaning of equilibrium. Equilibrium means by any condition, if my inside gas is completely in stopped condition. What is the meaning of stopped? There is no chance of temperature change. There is no chance of mechanical force change. When system is in equilibrium, means it is maintained the stable condition with the system and surrounding also, right? कहीं interact नहीं कर रहा है, then that thermodynamic system, my dear, is known as equilibrium condition. Okay, great, very good. Good afternoon, Chandan. How are you? Good afternoon. Okay, yes, Chandan Pashwan. Great. So in this case, quasi means almost. To make the process, we have tried to make any process as a reversible process. We have tried to discuss that quasi-static process, that is a very slow process. If I put the number of thin plate over the piston cylinder arrangement and I lift one by one, then this process will be a nothing but this process will be a quasi-static process. Okay, great. So when this process will be carried out in very slow manner, then this is the quasi-static process. Yes. And after that, yes, exactly. If I will talk about the mechanical equilibrium, what exactly question you have asked, my dear? If this one is the piston cylinder arrangement, so in the equilibrium condition, if my gas is apply the pressure of 2 bar, just for example 2 bar on the piston, then by to any reason, either due to the mechanical force or due to the weight of the piston or due to the external weight, your outward force must be this 2 bar, then and only then this system will be in mechanical equilibrium. If it is not, then make it in equilibrium, then check your property. तब जाके आप check करो. Okay, Chandan. Great. Good. Yes. Raju, is it clear? So, infinite slowness or very slow process is the main characteristics of the quasi-static process. And let me give you one more star point from here. Isothermal process, my dear. Can you write? Isothermal process is fast or slow process? Is very slow process. Very slow process, my dear. Isothermal process is very slow process, right? Okay. Next, this is the simple example I have represented. Each and every plate you are removing. Then again, it is example of very slow process, and my thermodynamic system is passing through the number of infinite state. If I'll talk about the pressure and volume diagram, like this my thermodynamic system is passing. I have removed the number of plate like this. So this thermodynamic system, when it is passing through the number of equilibrium state like A, B, C and D in such a way, then I can say this process is a reversible process. And at last I'll make a star point that all frictionless quasi-static process. All frictionless quasi-static process, not only quasi-static. Quasi-static process, my dear, process is reversible process. Is a reversible process. Okay, it is the reversible process. Great. All process you have defined, after that it will come into the picture. Sir, it was started from a state, then it will move towards the process, and finally it's a thermodynamic cycle. When number of processes are following in such a way that initial and final point are same, then this will be known as thermodynamic cycle. And for a thermodynamic cycle, my dear, difference of all property must be zero. So if I'll talk about change of temperature of the system, change of temperature of the pressure, change of temperature of the entropy of the system, change of volume for a system, if it is a thermodynamic cycle, it must be equal to zero. ये सारा जो चेंज होना चाहिए एक थर्मोडायनेमिक साइकिल के लिए जीरो होना चाहिए. आफ्टर 10 to 15 मिनट वी विल फील ये सेम टॉपिक रिपीट होगा जब आप एंट्रोपी टॉपिक पढ़ोगे. ग्रेट, गुड. नेक्स्ट, आइडियल गैस इक्वेशन एंड different process, my dear. If I'll write the ideal gas equation, then yes, PV is equal to mRT. That is the equation of a state. This is the equation for a state, my dear. For a simple state, I'll write, if it is a thermodynamic system like this and you want to represent a single state, for this single state you can write the equation. And if you will write the equation like this, P1 V1 divided by T1, it will be a relation between two thermodynamic state like this, T2. So this is not valid for a single state. This one is valid for a process, that is two state, for a process, my dear. Great. After that, I know very well that mass is nothing but this is the value of molecular weight into number of mole. So if I'll substitute the value of mass, then PV will be equal to N into M into R into T, and this value is nothing but universal gas constant. So in this case, if I'll again substitute the value, then PV will be equal to N into R bar. R bar is nothing but universal gas constant, my dear. This is also the ideal gas equation. This one is also the ideal gas equation. But again, can you write the answer? Where you want to use the second equation, where you want to use the first equation. This is first, this is the second equation. Both the thing, we all have written same. वही इक्वेशन है, लेकिन कहां पे यूज करना चाहोगे? क्योंकि R की जो वैल्यू है, that is specific gas constant. Gas constant, where I'll write that R divided by molecular weight, and R var is nothing but universal gas constant. Where you want to use this one? Can you write the answer? Where you want to use this one? All of you are writing, sir, ideal gas, my dear. Both are valid for an ideal gas. But point is this, where you will use this second equation and where you will use this first equation. This is a very big question. जब तक आपको यही नहीं पता चलेगा दोनों इक्वेशन सेम है, you can say where some number of mole are given, it means number of mole are so less that can be counted, then you can use the second equation. And when number of moles are very high, then you need to consider a single identity macroscopic approach. You will use the equation 1. So yes, this is 8.314 kilojoule per kg mole Kelvin. Okay, great. Per kg mole Kelvin. Good. Absolutely right. Great. Absolutely right. After that, let me draw the single process, my dear. Isobaric process. How exactly will you know that this is the example of isobaric process? Can any one of you tell me? And this is a very important point for all of you. Sir, आपको कैसे पता चलेगा कि ये जो सिस्टम है ये आइसोकोरिक ही है? How would you know this point, my dear? जल्दी से यार, जल्दी से आंसर दो. How would you know this point that my system is a isobaric, a system is undergoing a isochoric process? कैसे मुझे पता चलेगा isobaric? Very good. प्रशांत दास, sir, pressure will be the constant. अरे मारो उसे कोई. My dear, if the pressure will be the constant, this will be the isochoric? No, this is the isobaric. So in this case, isochoric means, my dear, it is the constant volume process. Means exactly whatever you want to do with the system, you are free to do. But you all are not able to change the pressure, the volume of the system. It means I am talking about rigid boundary. The boundary must be rigid. These are not flexible. Are you getting or not? You all, my dear, feeling or not? You all are talking about the rigid boundary. If your system is the example having the rigid boundary, then I'll say yes, it is the example of isochoric. Isochoric. Great. Sir, you will tell me, you all will tell me. When it is the example of isochoric process and heat is supplied to the system, then what should be the effect on pressure? Pressure पे क्या फर्क पड़ेगा? You all will write, sir, it will increase, my dear. Pressure will increase. So again from this diagram, pressure will increase like this. Pressure will increase like this. So my dear, if you are not feeling this important point that on the PV diagram how pressure is increasing, if you are not able to convert, this PV diagram into the real life situation, because from the real life situation to convert to draw the PV diagram or TS diagram quite easy, बहुत आसान है. Real life से PV diagram कोई भी draw कर सकता है. But if you are able to draw the PV diagram or connect the PV diagram with real life, that is the real study, my dear. Okay, so in this case, if I'll say that volume is constant, pressure is changing, then volume is constant, my dear. So in this case, my ideal gas equation for the process will be equal to P1 divided by T1 will be equal to P2 divided by T2. Okay. Like this. Correct. Next. Isobaric process. Sir, how would you know this is the example of isobaric process in real life? When this is the example of piston cylinder arrangement, simple piston cylinder arrangement, and my dear, heat is supplied to the system. Heat is supplied to the system, then inside pressure will try to increase. और जैसे ही प्रेशर इंक्रीज होने की ट्राई करेगा, क्या होने वाला है? Your piston will move in upward direction. That is the practical example of isobaric process. Practical example of isobaric process. Isobaric or constant pressure process. Pressure process, my dear. Good. If I'll draw the process, how this process will look like? Yes. If you are not asking with yourself after watching this diagram that sir, pressure is constant, how volume can be increased, then definitely you are not going to study the thermal in real way. Okay, so yes, it is example V1 by T1 is equal to V2 by T2. Yes, ideal gas equation, my dear. Different process we are going to study. Great. After that, isothermal process. Any one of you can tell me what is the main point of isothermal? Yes, yes, absolutely right. What is the main point of isothermal? Yes, sir. It is a very slow process. We have written now. It is a very slow process, my dear. You all mechanical engineer, you all mechanical warrior. Yes. Yes, very slow process. If I'll draw the diagram, then this is the PV diagram, my dear. I can draw like this. It is a hyperbolic process. Then answer will be P1 V1 will be equal to P2 V2 will be equal to constant, and temperature is equal to constant, my dear. Isothermal process. Great. Great. Yes. Adiabatic process. Any one of you? Very fast process. Or proper insulation. If I draw the diagram, PV diagram, 1 to 2, and PV raised to gamma is equal to constant. So in this case, answer will be equal to P1, V1 raised to gamma, it will be equal to P2, V2 raised to gamma, it will be equal to constant. At the same time, if I establish the relationship between T2 by T1, it will be equal to P2 by P1 raised to gamma minus 1 upon gamma. It will be also equal to V1 by V2 raised to gamma minus 1. And this is the process where all the three thermodynamic properties are changing. Even the heat transfer is zero in this process, my dear. Even the heat transfer is zero in this process. Great. So I'll write heat transfer is zero. Absolutely right. Sir, if I'll write the value of gamma from here, gamma can be written like Cp by Cv, and we have already studied with the help of Mayer formula. Cp minus Cv is equal to R, and I'll write, so from here, from both the equation 1 and 2, I can easily write that R is equal to R bar divided by molecular weight. So can I write, sir, R is only the function of molecular weight? Are you not feeling? R bar is 8.314 constant. Are you not feeling? R is the property of the gas, that is only the function of molecular weight. Great. Absolutely right. Yes, very good. And gamma is also equal to 1 plus 2 divided by degree of freedom of the molecule. Degree of freedom of the molecule. So can I write gamma is only the function of degree of freedom? Yes, degree of freedom. So gamma is the function of degree of freedom, R is the function of molecular weight. Sir, with the help of these both the equation, if you don't mind, can you calculate the value of Cb, my dear? Solve equation 1 and 2. Can I substitute R divided by gamma minus 1? Yes. Calculate the value of Cp, my dear. R divided by gamma minus 1. Sorry, gamma R into gamma minus 1. So again, if I'll ask to you very important question, this Cp is the function. Cp will be the function of, one is the molecular weight, second is the degree of freedom of the gas. So as much as high degree of freedom will be there, definitely different value of Cp and Cv will be there. So gamma is the property of the gas, that is a purely function of degree, purely function of degree of freedom, and R is the purely function of molecular weight. So this Cp and Cv, my dear friend, will be the function of molecular weight and degree of freedom. Great. Are you feeling or not? You all are getting or not, my dear? Good. So for different property or different gas, if you want the value of gamma, if you want the value of Cp for different gas, Cp, Cv, R will be gas, R will be different because ये सारी चीजें अलग है. Good. Absolutely right. Sir, liquid has two specific, no. Gas has two specific heat, Deepak. Liquid has only one specific heat. I'll tell you, don't worry about this. I'll discuss. Don't worry. Polytropic process, I need not to define again. In general case, N must be less than gamma and it must be greater than 1. N is the polytropic index, my dear. And after that, if I'll establish the relation, P1 V1 raised to N will be equal to P2 V2 raised to N will be equal to constant. In the same way, T2 by T1, my dear, it will be equal to P2 by P1 raised to N minus 1 upon N, and it will be equal to V1 by V2 raised to N minus 1 only. Great. Sir, what will be the heat transfer in this one? It will be not equal to 0. Yes, it will be the heat transfer. Yahan heat transfer hogi. Great. Good. So, after that, all of you have drawn a very simple process on the diagram. PV. That is nothing but polytropic process, my dear. Polytropic process. And this one is PV raised to N is equal to constant, my dear. Yes, absolutely fine. Good. At last, if I'll ask, what is the process that will be the example of polytropic? Can you write in the comment section? What is the process, my dear, which is the example of polytropic process? 1, 2, 3 or 4. What is the polytropic process? Can you write, all of you? Which is the example of polytropic process? Yes. Okay. Polytropic process will be third one. Great. Good. Okay. 0 to 3 will be the polytropic process according to number of you. Yes. Deepak, 3 will be the polytropic process. So can I write? On PV diagram, 0 to 1 is nothing but isobaric process. 0 to 5 isochoric, my dear. And you must know heat is rejecting in this process. 0 to 1, 0 to 2 isothermal, and 0 to 3 polytropic in general case, and 0 to 4 it is adiabatic process. Adiabatic process. So how I know this? कैसे मुझे पता चला? आंसर बहुत सिंपल है, because the slope of adiabatic process is maximum as compared to all other process. So I'll write that slope of adiabatic process dp over dv in adiabatic process, my dear, that is equal to slope of gamma time over dp over d in isothermal process. That is the reason this value is higher. And at the same time, I can also write that slope of this polytropic process, my dear, it is the n type of slope of isothermal process, my dear. And at the same time, I can also write that slope of adiabatic process, you need to write it is equal to gamma yn into slope of polytropic process. How many of you are able to understand this point? Again, I am not going to drive because this is not a lecture of entire derivation. This is the lecture so that each and every point, it should be in your mind. Ki, sir, yes, slope is completed. Great. Good. Very good. Next, we have moved to the second option, sir. That is the work done. Work done. All the process we have discussed. Let me connect these all the points. First of all, we have started with the system surrounding process and thermodynamic property we have already written. After that, we are going to discuss the work done, and after the work done we will discuss the heat transfer, then first law of thermodynamics. So in this case, let's start the topic of the work done. Yes, sir, work is said to be done by the system. It is equating while lifting the weight. If gas pressure is so much high that is able to lift this weight in the upward direction, then I can simply say that work is done by the gas. So in this case, if I calculate, this answer will be equal to, the inside pressure is P. This answer, my dear, will be equal to W work done will be equal to force into dx, or this value will be equal to, or let me write simple, that work done from this formula can be written like P into dV, and total work done between the all process can be written like 1 to 2 integration, that is PdV. So this is the base of all the non-flow work done, non-flow closed system work done, closed system work done. Can you write the answer? In this case, my dear, in this case, this work done is valid for a closed or open system. This work done is valid for a closed or open system, my dear. Yes, it is valid for a closed system. Very good. Closed system. Process, reversible process. Reversible process. But before moving towards the different formula of work done, I must know few important points regarding the work done. Let me make these all the star point for you. Sir, work done के लिए key point आप यहाँ से लिखिए. These all are the key point for the work done, my dear. Yes. These all are the key point for the work done. Work done is a path function. It is inexact derivative. It is the boundary phenomena. It is the transient form of energy, and it is not a property or the point function. It is not a property or the point function. And these type of question, ये आपने 5-6 क्वेश्चन न जाने कितनी बार देखे होंगे. If you have written the state PSC, ESC exam, even 1 or 2 times these type of questions are also asked in GATE exam. Great. Okay. I hope you have written all the points. Great. After that, let's try to discuss the work done. Sir, we have proved that work done was nothing but it was equal to integration of 1 to 2 into PdV. From here, I think if I am not wrong, then this area is also same. So can I write work done of a closed system will be equal to area of PV diagram. PV diagram about volume axis. Star point, my dear. Star point for all of you. All of you. Work done is great. So after that, what exactly you will do? After that, you will not ask to me, sir. So what is the transient form? Yes, yeah, if there are few points, if these points are not clear to you now, then feel free to ask, what is the transient form? Sir, if you are stopped at a certain condition, then you can't say work is done by the system. Work will come into the picture when my system change its position. It means work will be occurred only in the process, not at a state. So it will come into the picture when there will be a transient form of the energy, means it is a flow form of the energy. It cannot be stored into the system. Internal energy can be stored, chemical energy can be stored, but work cannot be stored. Clear? Okay. It will cross the boundary. Good. Sir, after that you will not ask what process or what is the formula of the work done for any process. No. You will ask to me, sir, give me the relationship between pressure and volume. We can give the answer of the work done, because from this point, after that I am not going to study the thermal for this particular point. If you are the real engineer, you will go with the math, क्योंकि area तो math ही बताता है. To calculate the area of the PV diagram, it is a purely the topic of mathematics, my dear. So work done will be the area, and this is valid for the closed system, my dear. Closed system. Closed system. Valid only for the closed system. Okay. And yes, process must be the reversible process. Okay. Process must be the reversible process. After that, if nothing is known to you, very good. In this case of process, establish the relationship between pressure and volume, find the area, answer of the work done. But there are 5 process, my dear, we have already established. 5 process जिनका आपके पास relation है between the pressure and volume. At least drive the formula for that. At least drive the formula for that. Work done. First of all, define sign convention. Sir, if work is done on the system, like this, work is done on the system, then it will be taken with the negative sign, and if work is done by the system, it will be taken with positive sign. Means if I am going to consider this as a system, gas as a system, so if it is lifting the piston, this is the example of positive work, means process of expansion, and if it is compressing the piston, great. Yes, absolutely right, Deepak. Yes, if it is compressing the system, you will take the positive work done. In expansion, work done must be the positive, my dear. I'll not write for the compression. If the work done for expansion is plus, work done for the compression, it will be a minus. This is the diagram of PV. Okay, good. All important point we have just made here. After that, we are going to derive the number of different formulas. Sir, for these all the value we have already calculated these all the formulas, and after that we are going to write what will be the formula of the work done for different process, my dear. Yes. This P1, sir, for an ideal gas, just a minute. For an ideal gas, sorry, just a minute. Okay, sir. Yes. Okay. Just tell me, is everything fine now? Okay, sorry. Okay, is everything fine? Great. Sir, for an ideal gas, can I write the value of this is nothing but M into R into T2 minus of T1. This is nothing but P V2 minus V1 I have replaced by MR T2 minus T1. Similarly, can I write the work done formula also in this case? Can I write the work done formula? Like work done in this case, P1 V1 is okay. Ln V2 by V1 for isothermal will be equal to P1 by P2, my dear. It will be also equal to P1 V1 is equal to MRT1 ln V2 by V1. So these all formula are the work done formula for closed system. After that, at the same time, can I write P1 V1 MRT1 minus of T2 divided by gamma minus 1. My dear, one important point we have discussed. What is R divided by gamma minus 1? What is R divided by gamma minus 1? Is it CV now? T1 minus of T2. Yes. At the same time, this term will be N. So in this case, I'll also write this value will be equal to MR T1 minus T2 divided by N minus 1. Great. Just write in the comment section, is everything clear till now? Is everything clear? Okay, good. Work done, we have calculated. After that, come to the next topic, that is the heat transfer. Sir, so we have these all the formula in a single table, and I'll suggest to all of you that combine these all the formula in this type of table जिसमें आपके PV diagram भी हो, PV-T relation भी हो, heat transfer भी हो, even you are going to combine the work transfer also. Combine each and everything in a single table and then see the magic. Because after that you need not to remind each and everything again and again. Great. Okay. Sir, why it's CV? It's not CV. My dear, in the last, if you will go back to 3-4 slide, then R divided by gamma minus 1 SK, we have written that the value of CV is equal to R divided by gamma minus 1 and the value of CP will be equal to gamma R upon gamma minus 1. We have written. Even one more point, my dear, you write here that MCV delta T, in the next slide we will write that is U1 minus of U2, means MCV delta T for an ideal gas, it is nothing but change of internal energy. Change of internal energy. Great. So I have not written this point. Okay. Correct. Come back. Is it clear? SK, it was your question. Sir, first of all, we move forward. उससे पहले आप मुझे एक क्वेश्चन का आंसर दे दीजिए. First of all, give me a simple answer of a question. Are you making your proper notes? Short notes बना रहे हो ना आप? Or you all are thinking, sir, at the end of this session we will download the PDF or PPT? What exactly you all are doing? What exactly you all are doing? Yes, Onka sir. Good afternoon, sir. Good afternoon. Onka sir join हुए हैं. Just like the session. यार कमेंट सेक्शन में कुछ दिखाओ, आप आग लगनी चाहिए कि हाँ देयर आर द नंबर ऑफ 2-3 hours session I am going to discuss and all about the thermodynamic we are going to discuss. Yes, there must be the same level of energy flow in your mind and heart. Yes, exactly. Okay, good. Otherwise उधर सोफे पे बैठ के देखते रहोगे तो कुछ नहीं होने वाला है. Right? Okay. Thank you all. Come back. Okay, heat transfer. Sir, we have discussed all the different process, relationship of all the different process, work done for all the process. Heat transfer we are going to discuss, and after that directly we will jump on the first law of thermodynamic. First law of thermodynamic, directly we will jump. Okay, great. Sir, if you are talking about the heat transfer, the temperature of this body, my dear, is T1. Temperature of this body is, my dear, T2. If temperature of T1 is 100 degrees centigrade, temperature of this T2 is equal to 30 degrees centigrade, my dear, then one point is very clear to me that if temperature difference is maintained, then heat will be transferred from higher temperature to lower temperature. So first thing, can I say temperature difference must be maintained between two bodies. Between two bodies for heat transfer. For heat transfer. Very good. Very important point. After that, how much amount of heat this body can absorb, that will purely depend upon the mass of the system itself, and how much temperature can change, that is nothing but heat transfer, my dear, can be written like M into C into dt. If I'll talk about this MC delta T, then C is nothing but that is the specific heat, my dear. This one is the specific heat. Can you say specific heat is nothing but it is a thermal inertia? So this C, if I'll talk about, that is M into C, that is nothing but heat capacity of the system. And this point is going to define the number of points. This one, unit of this kilojoule per kg Kelvin, my dear. Unit of this one is kilojoule per Kelvin only. Mass is multiply. All of you are not feeling that this capital C is the heat capacity. What exactly we are going to discuss, if I'll write capital C, then heat transfer, my dear, will be equal to capital C into dt. This formula I think you have used in HMT, my dear. ये formula आपने HMT में use किया होगा. Yes. Okay. So this C, what heat capacity exactly you are writing, my dear? Are you not feeling this heat capacity is a thermal inertia? This C is nothing but it's a thermal inertia. Say yes or no? I'll tell you why it is thermal inertia. I'll tell you why it is thermal inertia. Reason? Sir, heat is supplied to the system, my dear. Heat is supplied to the system and it will try to increase the temperature. Whenever heat will be supplied to the system, it will try to increase or change the temperature. But my specific heat or heat capacity, that is capital C, my dear, will play a very important role in this concept. How? If I will have the higher value of capital C, then change of temperature will be minimum. If I'll have the lower value of capital C, then change of temperature will be maximum. So ultimately, if I'll have plus value of capital C, then change of temperature during the heat supply will be plus. If I'll have negative value of capital C, then change of temperature will be negative when heat will be supplied. So all about we are going to discuss, that is temperature change is purely dependent upon heat capacity. That is the reason it is nothing but it is a thermal inertia. So how temperature will change of the system or body, it will be a purely the function of capital C. Is it clear to everyone? So in this case, I can yes also say that this heat is the cause and this change of temperature what is occurring here, that is the effect. And this MC is the inertia, what exactly does not want to change the effect, to produce the effect. All of you are getting this point? So after that, there are very few important points I am going to discuss. What is specific heat? My dear, if this specific heat is higher, then what is the same temperature change? It must be lower, na? Lower for same heat transfer, for same heat input. Great, absolutely right. If the C, I'm not going to write lower. If higher, then it will be okay. My dear, if the C will be infinite, C will be the infinite. What is the change of temperature, my dear? Very, very, very high. 0. Example. Phase change process. Number of time this question is asked to us. What is the specific heat during the phase change process? During the phase change process, specific heat is equal to infinite. That's why change of temperature is 0. Great. Good. if specific heat is negative, then change of temperature will be negative during the heat supply. If you say always that, sir, if heat will be supplied to the system and temperature will increase, no, it's an incomplete sentence. If a specific heat is negative and when at that time you are going to supply the heat, then yes, supplying of heat can decrease the temperature also. Okay. So if you say that temperature will always increase, make a very important stop point, my dear, here. If C is equal to positive, then only change of temperature will be positive during the heat supply. Great. Is these all 4 स्टार पॉइंट आर क्लियर टू ऑल माय डियर? क्या ये चारों स्टार पॉइंट सभी को क्लियर हैं, समझ आए हैं अभी? राइट इन द कमेंट सेक्शन. Is these all 4 star point, my dear, are clear or not? Okay, great. Good. All of you, write in the comment section. Okay. Great. Very good. After that, my dear, sign convection or sign convention of the heat transfer. Sir, if it is the system, and again, if I am going to supply the heat to a system, that heat supply to the system, that will be taken as positive, and if I am going to reject the heat from the system, that, my dear, will be taken as negative. Heat supplied to the system is positive, heat rejected from the system is negative. So when you will talk about the specific heat, just a minute, when you will talk about the specific heat, so for the liquid, there is only a specific heat, one specific heat, that is C, or you can write Cp. There is no issue. But for gas, my dear, there are 2 specific heat. One is Cp and second one is Cv. Cp means a specific heat at constant pressure. And Cv means a specific heat at constant volume. Okay, good. Constant volume. And we know very well that Cp is greater than Cv for all the real gases, and Cp minus Cv is also equal to R. This term we have written number of times. Again, you can say, sir, prove it. We are not going to prove here. Reason, it is not the session for explain each and everything. Otherwise, for next 1 hour, this will be the topic. I have just explained this topic in number of session. So you need not to worry about this. Just write these all the star point as a star point. After that, sir, zeroth law. Zeroth law of thermodynamics, simply, if the temperature of A is equal to the temperature of B, and my dear, temperature of B is equal to the temperature of C, then according to zeroth law of thermodynamics, temperature of A is equal to temperature of B is equal to temperature of C. You can say, sir, it is very easy statement, but again, because you all have studied the mathematics. जब आप रियल थर्मल में आते हो तो उस टाइम पे कोई आइडिया भी नहीं था व्हाट आर द एब्सोल्यूट टेम्परेचर स्केल, बट ही प्रूव्ड एट दैट टाइम. Zeroth law. Okay, great. Sir, if I'll ask a simple question, what is the application of zeroth law? Then this is nothing but to measure the temperature of the thermometer, to measure the temperature of the body with the help of the thermometer. Now you can ask, sir, what is this principle or how we use this concept to measure the temperature of the body? Very simple concept, my dear. First, according to thermometer, we measure the thermometric property. What is the meaning of thermometric property? Which are changing with respect to temperature. These are the thermometric properties. So when we measure the thermometric properties, first you measure these all the property, and after that you will calculate the temperature. Temperature is not measured, temperature is calculated. So on the based on thermometric properties, my entire thermodynamic is divided into 5 types. One, if I'll talk about, yes, it is thermistor. What property change with respect to time? Sir, resistance. Principle, Wheatstone bridge. Thermocouple, yes, what property will change with respect to temperature? Sir, EMF. When two dissimilar metal are connected at a different temperature, then an EMF generated between the bodies, and that effect is known as Seebeck effect. Great. Constant volume gas thermometer, property pressure. Constant pressure gas thermometer, property principle Charles law, and pressure volume. Hg in glass thermometer, what property changing with respect to temperature? Length. So you will focus on the length, my dear. You will focus on the length, and then temperature will be calculated. So these all are the property for ESC point of view. It's a very important slide. Number of time when you feel that there are the number of match of the following question, and these type of question ask. The one type of thermometer is given to you, and it is asked what are the thermometer property, what are the thermometric principle. Okay, clear everyone? So when thermistor will be given to you, you will not measure the temperature directly, you will measure the resistance first. If Hg in glass thermometer is given to you, you will not measure the temperature, my dear, you will measure the length first. Great. Write in the comment section, is everything fine till now? Is everything fine, my dear? Just write in the comment section, all of you. Great. Very good. Absolutely right. Shubham, Raj, great. Good. So let me write how the temperature is measured. How the temperature is measured. So simply, we know very well that all the temperature profile are calibrated in linear line. And if it is the question of two reference point, generally we consider the boiling and freezing point, my dear. That we calculate any property like resistance, we calculate the resistance at any two properties, that is the boiling point, temperature. If it is the example of thermistor, the freezing point temperature, that is I, this is T0, and at which you want to calculate the value of temperature. That is the value of R, my dear, you want to calculate. This is the first reference point, that is R0, and this is the second reference point, that is Ri. So if I apply the linear interpolation, I'll get the simple answer, T minus of Ti divided by T0 minus of Ti will be equal to R minus of Ri divided by R0 minus of Ri. So this is based on two reference point. After that, this Ri and R0 are given to me because these are the reference point. Yes, these are the two reference point concept, and if it is the single reference point, my dear, single reference point, then it is nothing but triple point. It is nothing but triple point it is considered, at which the temperature of any arbitrary resistance can be written like 273.16 Kelvin into resistance whatever you have measured divided by resistance at triple point. Yes, so it is very easy to calculate, and what answer you all are getting, that is in Kelvin. So if you are calculating the answer with two reference point, first formula, that is the linear interpolation we use, and if you are using single reference point, then only the single formula related to triple point we consider. Okay. So at any particular point when it is the Hg in glass thermometer, we calculate the value of length at which the value of temperature I need to calculate. उसी के बाद हम क्या करेंगे, रेफरेंस ट्रिपल पॉइंट पे लेंथ ऑलरेडी रेफरेंस बना हुआ है, मेजर कर लेंगे and in this case at any given temperature you are, or at any given point you can calculate the temperature. ये आपका जो आपने थर्मोमेट्रिक प्रॉपर्टी कन्वर्ट की थी, conversion of the thermometric property is replaced by temperature, my dear. Great. Temperature. Then how these all the temperature scale change, how these all the temperature, because right now you have just calculating or you have just calculated all the property in Kelvin or degree centigrade, but when you will establish the relationship, then how will you establish? Then one thing I know, that all the temperature scale are arbitrary. What is the meaning of this? All the temperature scale are going to follow this important relation, any temperature scale, T0C plus of V, my dear, like this. What exactly you need to follow after that? You A and V are the arbitrary constant. You just put the value degree centigrade and Kelvin. You just justify these two value and you will get the answer. So if I'll write the answer, then T Kelvin will be equal to T0 centigrade plus 273.15 Kelvin, my dear. Like this. Similarly, if you will establish the relationship, what is the Kelvin and Rankine scale? What is the Kelvin and Rankine scale? So I'll write T of Rankine divided by 1.8. You need to satisfy the equation only and you will get the exactly correct answer. बिल्कुल सही आंसर आपको देखने को मिलेगा. Yes. Good. In the same way, if you want to calculate the Fahrenheit, it is for your task. Convert the Fahrenheit scale and degree centigrade scale. इसको आप यहां पे लिखना. Convert the Fahrenheit scale into degree centigrade. So my dear, we have discussed each and everything related to all process, related to work done, related to different thermodynamic process, work done. This is the longest chapter we have discussed. सबसे बड़ा चैप्टर ये है, उसके बाद बहुत आसानी से छोटे छोटे चैप्टर हैं, कुछ कुछ पॉइंट अपन को डिस्कस करने हैं और उन सारे पॉइंट्स के बाद each and every chapter is going to be a very easy and very short for you, my dear. This is the basic chapter of the thermodynamic we have discussed. That is the first chapter we have discussed till now. After that we are going to start chapter number 2, my dear. Chapter number 2, that is first law of thermodynamics. If you want to take break, very good, very good. Shubham has written the answer. Let me rewrite the answer and you all write the answer in comment section. Are you all of you are writing the answer like this, that 9/5 into T0C plus of 32. Are you able to solve this problem, yes or no, by following Fahrenheit and degree centigrade? Are you able to solve or not, my dear? Write in the comment section. Okay, very good, great, good, absolutely right. Sir, let's start the second chapter, my dear. Very important chapter, very crucial chapter for all the GATE aspirant. इसमें से आप मान के चलो कोई साल ही ऐसा जाता है जिससे वर्क डन या हीट ट्रांसफर से क्वेश्चन ना आता हो. Either you will feel the question from work done or you get the question from the first law of thermodynamics. Great. Sir, what is the meaning of this? First of all, let me introduce. For a closed system undergoing a cycle, the total heat transfer, my dear, it will be equal to total work transfer. The first important formula. Total heat transfer, my dear, it will be exactly equal to total work transfer. If I draw a simple cycle here, or if there are the number of process in a simple cycle, number of process are there in a cycle, then for a thermodynamic cycle it can be written that heat transfer in 1 to 2 process, heat transfer in 2 to 3 process and heat transfer in 3 to 4 one process. Algebraic summation, it will be exactly equal to work transfer in 1 to 2, work transfer in 2 to 3 and work transfer in 3 to 1, my dear. This one is nothing but 1 to 2, 2 to 3 and 3 to 1. You have drawn any cycle like this. You can draw any cycle. 1, this is 2 and this one is 3. On PV or TS diagram you can easily draw. And after that you can ask what is the work done or what is the relationship between the work done and heat transfer. Sir, remember this point, only for a cycle, not for a process you are going to apply this concept. Only for a cycle you are going to apply this concept. Sir, is it valid for closed? No. Is it valid for reversible or irreversible? No. It will be valid for reversible and irreversible both, my dear. Cycle both. Cycle both. Valid for both the cycle. If friction is not there, it will be a reversible cycle, it will be valid. If friction will be there, it will be reversible cycle. Yes, this equation will be valid. But let me clear, it is total summation, not the input. In this one, input is considered, output is considered, everything is considered. Heat supply, heat rejection, both are taken care. Okay, good. Very good. After that, heat I have introduced. Let's try to discuss few important points regarding the heat, my dear. Yes, similarly we have discussed a very important point or the consequence of the heat transfer. So consequence means application of first law of thermodynamics for a closed system. So yes, we have proved heat transfer is a path function, my dear. Heat transfer is the inexact differential. Heat transfer is the boundary phenomena. Heat transfer is the transient form of energy. Yes, it will be come into the picture when there will be a process form of energy, and heat transfer is not thermodynamic property. These are the most important properties or most important characteristics of the heat. Most important point regarding the heat. Heat transfer is a path function. You will write this term by inexact derivative. Inexact derivative, not exact derivative. Great. Good. After that, important point regarding the heat and work. All the star point we have written, my dear. What we have concluded, everything we have written. Both are yes path function. Both are boundary phenomena. Both are not the property. Both are inexact derivative. And heat and work both are the transient form of energy. We absorb heat and work only whenever process will be there. जब तक प्रोसेस नहीं होगा तब तक आपका हीट और वर्क का कोई मीनिंग नहीं होगा. They can lose the significance when process is completed or process is not started. Is that clear to everyone? जल्दी से बता दो, सारे स्टार पॉइंट आप तक पहुंचे? Are you able to feel these all the star point regarding the heat? That is the first consequence of the first law of thermodynamics, my dear. That is the first consequence of first law of thermodynamics. Just write in the comment section. Is it clear to everyone or not, my dear? Write in the comment section what exactly you all are doing. Just write in the comment section. Till now, is everything clear or not, my dear? Yes. Very good. Shubham. Great. All of you. Good. Yes. Great. After that, energy is the thermodynamic property of a system. Energy means dE is the property of the system. That will be equal to change of kinetic energy plus change of potential energy plus change of internal energy. If I neglect kinetic and potential energy for a closed system, if I neglect this change, my dear, then I'll write my change of internal energy will be property of the function, that will be a change of internal energy for path A, change of internal energy for path B, चेंज ऑफ इंटरनल एनर्जी फॉर पाथ सी। मतलब आप किसी भी पाथ के लिए लेके जाओ, ये प्रॉपर्टी चेंज होने वाली नहीं है। सो इंटरनल एनर्जी इज अ पॉइंट फंक्शन, इज अ प्रॉपर्टी, एंड यस इंटरनल एनर्जी इज इन एग्जैक्ट और एग्जैक्ट। इंटरनल एनर्जी, कैन यू राइट द आंसर, इज एग्जैक्ट डेरिवेटिव, एग्जैक्ट डिफरेंशियल। एक भी पॉइंट आपसे मिस ना हो जाए, differential. Second consequence of the first law of thermodynamics, my dear. Second consequence of first law of thermodynamics. Yes. Second. When I talk about the stored form of energy, that is the internal energy, जो आपने बात की थी, या फिर काइनेटिक एनर्जी या फिर पोटेंशियल एनर्जी, ये सारी एनर्जी की जो बात करने आ रहे थे। यस, देयर आर टू फॉर्म ऑफ द एनर्जी। वन इज द मैक्रोस्कोपिक फॉर्म ऑफ द एनर्जी। Macroscopic. In macroscopic form of energy, we always deal about the outside reference, means when my molecule are interacting with the boundary of the system, then that involvement of the energy is known as macroscope energy. Like kinetic energy is the example of macroscope. Even potential energy is the example of macroscope. But when you will talk about the microscope form of energy, दो टाइप की एनर्जी होती है। When you will talk about the microscopic form of energy, that related to the molecular structure and behavior of the molecule, this is purely dependent upon the intermolecular behavior of the molecule. It is not interacting with the surrounding, and this microscopic form of energy is nothing but, my dear, is internal energy, is internal energy. So when you will write this E, that is the internal energy, kinetic energy and potential energy, sir, these two, my dear, these two are macroscopic form of energy. Macroscopic form of energy, but this one is the microscopic form of energy. Microscopic form of energy. So whenever you will talk about the total energy, then total energy will be the combination of microscopic form of energy and macroscopic form of energy, whatever I have written at the last page, my dear. Great. It will be a combination of macroscopic and microscopic form of energy. Good. Sir, third one. Consequence of the first law of thermodynamics. We know very well from the last lecture, last slide, that del Q can be written like del W plus of du, my dear. Can you write the answer? This is the first law of thermodynamics for a process. Yes, valid for reversible or irreversible or both. Can you write the answer? Both. It will be valid for both the process, because this is a simple difference of heat and work that will be nothing but exactly equal to change of property, and change of property is nothing but, my dear, it is a thermodynamic internal energy. That is a point function. Yes, but at the same time, this is the one, at the same time, if I'll write that del Q will be equal to du and substitute the value of pdv, this is also the first law of thermodynamics. This one is also the first law of thermodynamics, my dear, valid for, can you write, reversible process only. Reversible process only. If we will deal with next process, that is del Q is also equal to dH minus of BDP, that is the enthalpy. then this term is also valid for reversible process only. So we have three important equation for the first law of thermodynamics. One equation valid for all the process, either it is reversible, irreversible or any process. Second and third relation, it is valid for reversible, valid for only the reversible process. Okay, great. So after that energy of universe remain constant. Yes, I'm not going to write this point. Energy of universe is always constant. Yes, that is total energy we are talking about. Yes, total energy of the entire universe is not going to change. And last one, PMM1 is not possible, my dear. PMM1. If PMM1 is possible, then what will be the condition of PMM1? They were talking about to design a machine that will continuously produce the work done from any zero input. If this PMM1 is possible, can you write for which efficiency they were working? क्या efficiency होती इस machine की? Check it. What was the efficiency if this machine is possible, my dear? What was the efficiency? They were talking about but PMM1 violate first law of thermodynamics. If it will violate first law of thermodynamics, which is the law of nature, that is the reason it is not possible. It is not possible, my dear. This one is not possible. Next, enthalpy of the thermodynamic. Enthalpy is the thermodynamic property of the system. Yes, U plus PV we write frequently. That is the reason enthalpy is the property of the system. Unit kilojoule, extensive property, and yes, this value can be written like specific enthalpy. That will be a perfectly example of intensive property. So these all are the consequence of the first law of thermodynamics. These all are the consequence of the first law of thermodynamics. Now after that, sir, if I'll write the Joule's law, we have written the Joule's law after the consequence of the first law of thermodynamics. Can I write from here Cp minus Cv? Already we have written, that is the Mayer's formula. And according to Joule's law, internal energy is only the function of temperature. This is the Joule law, my dear. Only the function of temperature. Internal energy is only equal to mCv T, and enthalpy will be equal to mCp T, my dear. And these all are valid for an ideal gas equation. Ideal gas. These are the three important relation. Sir, till now almost everything you have completed related to first law of thermodynamics for closed system. अगर एक पॉइंट आपको पता चल जाए, सर क्या आप फर्स्ट लॉ ऑफ थर्मोडायनेमिक की हेल्प से हीट ट्रांसफर कैलकुलेट कर पाए अभी तक? डू यू हैव एनी फॉर्मूला ऑफ द हीट? कैन यू राइट द आंसर? Do you have any formula of the heat transfer? Can you write the answer, my dear? Till now, U is the function of temperature only. Yes, great. No, till now we don't have any formula of the heat transfer. So what exactly we will do? We apply a very basic concept, my dear, that we know very well, that the value of the heat transfer we have calculated, my dear, work done of the system plus of change of internal energy of the system. So again, my dear, this is the basic formula to calculate the value of the heat transfer. If anything given or not given, if you know this formula, then in any particular process you can calculate the value of heat transfer. बड़ी आसानी से आप heat transfer calculate कर लोगे. But again, I know the value of, so this is the basic formula. Basic formula to check heat transfer or to calculate heat transfer. Calculate heat transfer, my dear. But I have the number of formula for the work done. In the last slide we have drive. So if I'll substitute the value of the work done formula and internal energy formula from the previous slide, then for the different process, I'll have the different value of the heat transfer. I've already calculated. We all have already calculated, and let's try to have that value in the tabular form. Yes, these are all the value in the table form. Sir, 1 constant pressure process, yes. N was 0. That was slope. Heat transfer in or heat supply in this process is mCp delta T. That is the change of enthalpy in isobaric process. And this is, yes, work done we have already written, my dear. Relationship we have written, and a specific heat we have also written. Good. If I'll talk about the constant volume process, very good. Total thermodynamic today we will complete. Basic thermodynamic total we will complete, my dear. Don't worry. Yes, come back. Constant and heat transfer, change of internal energy for an ideal gas. Work done, it is 0, and this relation we have established. Specific heat, yes, it was Cv. Similarly, if I'll write value of the work done for isothermal process, in isothermal process internal energy will be 0. Let me write here, change of internal energy will be 0, my dear. So yes, PV relation will be written like this. Work done will be equal to heat transfer, and in this case reversible adiabatic process, N is equal to gamma. Heat transfer is 0. Adiabatic process is there. Work done is given here, and it was also equal to mRT1 minus of T2, my dear. We all have written divided by gamma minus 1. So in this case, relation we have established, and a specific heat is 0 at last. What is the polytropic heat transfer? Polytropic heat transfer can be given like Cn, polytropic index T2 minus of T1, like this value. These all three formula are there, and like this value. So if I'll compare these all the values, then this Cn and this bracket value can be written as specific heat. So specific heat formula I'll write somewhere here, my dear. I'll write somewhere here. That is the specific heat formula. So in this case, if I'll just do, or if I'll start the analysis of the polytropic process, then I get that polytropic specific heat can be written like Cv into, what was the previous one? Gamma minus N upon 1 minus gamma, 1 minus N. Sir, now you all will write the answer. All will write the answer, and now you will just recall each and every point of the first slide. If gamma is greater than N, gamma is greater than N, in general case, N is less than gamma, what is the value of polytropic process? I mean, it is positive or it is negative, my dear. Write the answer. Sir, gamma is greater than 1, so this numerator will be positive, but denominator will be negative, because N is greater than 1. So in this case, what will be the answer? It will be positive or negative. Can you write the answer? Will it be positive or negative, my dear? Should be positive or negative. Write the answer fast. Yes, sir, it will be negative. So in general polytropic process, negative, it will be minus. In general polytropic process, my dear, when a specific polytropic heat is negative, you supply the heat. You supply the heat to the system. Heat to system. Can you write in the comment section? What is the change of temperature, my dear? What is the change of temperature? Remember the first slide. If you are in the class, from the first slide, you will be able to give the answer. If heat is supplied to the system when polytropic or a specific heat is negative, then supply of the heat will give the opposite result. Temperature decrease, my dear. Decreases. Even you are supplying the heat, but temperature will decrease in this case. Reason is specific heat is negative. After that, I'll give you a homework, my dear. After that, I'll give you the homework. You need to consider if N is greater than gamma, then yes, this C polytropic at that time, my dear, C polytropic at that time will be equal to positive. Then you need to write the answer, what exactly will happen in that condition. Cp will be the plus, what exactly will be happen, you need to write the answer in that condition. क्या होगा? Good. Okay, let me write. You are not going to write, I know very well. तो आप पूरे notes बना रहे हो तो आप यहीं पे बना दो. When heat is supplied to the system, then exactly temperature of the system will increase, my dear. Temperature of the system will increase. Yes, it will increase. All of you? Yes, sir, it will increase. Good. This is all about the heat we have discussed. After that, let me start the topic of free expansion, and in this way, the first law of thermodynamics for the closed system will be over. First law of thermodynamics for a closed system will be over. So after that, expansion of the gas against the vacuum is known as free expansion. Great. Can I know? Yes, it is the example of expansion. Sir, here, this is the pure gas, and in this one, sorry, pure vacuum, and in this section, there is the pure gas like this. यहां पे आपकी प्योर गैस कुछ इस तरह से फिल है, माय डियर. यहां फिल है कुछ इस तरह से. Very high pressurized gas. What is the work done in this case? Work done in free expansion, it will be 0. Work done in the free expansion, it will be never equal to PdV. In this case, it will never equal to PdV. Why it is never equal to PdV? ये इसके equal नहीं होगा, because free expansion is very, very high irreversible process. And in this case, I can write internal energy will be not going to change. That is, the initial is equal to final. Temperature is not going to change. Initial is equal to final, and enthalpy is also not going to change in case of ideal gas. In case of ideal gas, these all properties are not going to change. Great. So in this way, my dear, we have completed each and everything regarding the closed system. Your closed system is over. After that, let's start the topic of open system. Free expansion we have completed. Yes, let's start the problem of first law of thermodynamics for open system. Sir, open system, my dear. Conservation law of mass. Change of the mass in the control volume, it will be equal to conservation, what mass is entering and leaving the system, and if it is the SFEE, then there is no change of the mass in the control volume. So can I write? If this value is 0 for SFEE, then mass flow rate at inlet and mass flow rate at outlet is absolutely fine, absolutely same. Similarly, if I'll write the enthalpy equation, H1 plus of 1 by 2 mc1 square plus of mgz1 plus of q is equal to H2 plus of 1 by 2 mc2 square plus of mgz2 plus of W, control volume, W of the control volume. So this is the conservation law of energy, or simply you can say this is nothing but this is the example of SFE. यही आपकी SFEE है my dear. This is the SFE. Okay, SFE. If you want to write this SFE in the specific term, yes, H1 plus of C1 square by 2 plus of GZ1 plus of Q is equal to H2 plus of C2 square by 2 plus of ZZ2 plus of small control volume work done. This is the work done, or this one is nothing but SFEE equation that will be valid for every प्रोसेस माय डियर. अगेन एक ही पॉइंट यहां पे आपको बताना होगा, इस वैलिड के लिए अगर आपको ये इक्वेशन वैलिड करनी है तो कौन सा पॉइंट आपको पता होना चाहिए? एनी वन ऑफ यू? आई मस्ट नो माय सिस्टम माय डियर इज द एग्जांपल ऑफ, जस्ट अ मिनट, कम बैक. Yes, my system must be the example of open system my dear. मेरा जो सिस्टम है वो ओपन सिस्टम होना चाहिए. Then it is okay. Great. Okay. Good. Then it is okay. Open system होना चाहिए. On any open system you can apply this concept. Let me apply the application of this first law of thermodynamics. Yes, first is the nozzle my dear. First is the nozzle, but let me clear. Each and every concept is based on SFE. तो आप SSE तो लगाओगे ही, लेकिन अगर ये assumption satisfy होती हैं गेट क्वेश्चन, किसी भी क्वेश्चन में, तो yes, you will write final velocity in this case will be equal to 2 into H1 minus of H2 my dear. But H1 and H2 must be in joule per kg. Joule per kg. This is the basic formula of the nozzle you are going to apply. This is the basic formula of nozzle you all are going to apply. Yes, great. After that, sir, sound, audio, video both are clear? Can you write in the comment section? Audio, video both are clear or not? Audio and video both are clear, yes or no? Just write in the comment section. Write in the comment section, is everything fine? Yes sir. Okay, these both the part. Audio, video, yes sir, clear, very good. So in this case, if I'll talk about the compressor, yes, then work done in a compressor if these all the important points are assumed. Otherwise SFE is more than sufficient. If these all points are assumed, then yes, it is equal to H1 minus of H2. This will be in kilojoule per kg. If you want to convert it into the kilowatt, what exactly we all will do? Multiply by mass flow rate, SFEE. Then next, yes, it is the case of turbine. The same work done if all the assumptions are valid. So I'll write the turbine will be equal to H1 minus of H2. That will be equal to kilojoule per kg my dear. And if you want to convert it into the Kelvin, kilowatt, then definitely your assumption will be changed. Next, boiler. If it is no work done, no kinetic energy change and no potential energy change, then yes, specific heat supply in the boiler will be equal to, again, if it is this is the boiler, and H1 at the inlet enthalpy is H1, outlet enthalpy is H2, my dear. So in this case, this value will be equal to H2 minus H1, and this heat supply will be equal to kilojoule per kg. And if you will talk about the answer in kilowatt, you have to take this value in mass flow rate. You have to multiply this value with mass flow rate. Then last process is the throttling process. Throttling is very highly irreversible process. Very highly irreversible process. If you want to take the example, yes, flow through the partial open valve, flow through the venturimeter, flow through the porous or capillary tube. These are the example. Can any one of you write in the comment section what is the example of throttling process? Throttling process का example क्या है? Example नहीं, sorry. Which property remain constant in throttling process? Which property remain constant in throttling process? Can you write? Which property remain constant in throttling process, my dear? Can any one of you write? Very good, very good. Yes, great, absolutely right, all of you. Sir, enthalpy remain constant. So in this case, if I'll write in throttling process, no work done, no heat transfer, no change of kinetic energy, no change of potential energy. In this case, enthalpy, total enthalpy of the system before and after the throttling process is not going to change. Is not going to change. This is the example of throttling process. Yes. After that, again, if it is a problem of unsteady flow, my dear, unsteady flow, that inlet and outlet are not same for us. Like this. This is the inlet. Different mass is entering and different mass is leaving to the system. Very important concept. So in this case, this conservation law of energy will be applied, that rate of change of mass per second in the control volume, it will be equal to mass flow rate at inlet minus of mass flow rate at outlet. This is the conservation law of mass. If I apply conservation law of energy, sir, is the example of no. It is against the vacuum, but again it is not vacuum. If I'll talk about this, then total rate of change of energy in the control volume, it will be equal to mass flow rate at inlet into HI plus mass flow rate MI into C1 square plus mass flow rate at inlet Z1 plus of heat transfer rate minus ME HE plus 1 by 2 ME C2 square plus ME dot mass flow rate at exit ZZ2 plus of work done in control volume transfer rate. No. If I neglect the kinetic and potential energy, then the same equation will be converted into, same equation, my dear, it will be converted into MI into HI, mass flow rate at inlet, plus of heat transfer minus of ME into HE minus of work transfer in the control volume. So this is the USFE. So how will you use this equation? इस इक्वेशन को पुराने इक्वेशन से जो अभी SFE इक्वेशन लिख के आए हो, इन दोनों इक्वेशन को डिफरेंस कैसे करोगे माय डियर? How will you make the difference between these both the equation? Can any one of you write the answer? इन दोनों इक्वेशन में डिफरेंस कैसे बनाएंगे हम? Anyone? Any one of you? Sir, whenever there will be an accumulation of mass, whenever there will be an accumulation of energy, or there will be an accumulation of both, we will apply this equation. जब कभी भी accumulation होगा, like, let me give you the example. Like this is the example. आप air को fill कर रहे हो इस evacuated chamber में, my dear, right? कौन सा concept apply करोगे? Unsteady flow का. Unsteady flow क्या कहता है? Total change of internal energy in the control volume, if I assume this as a control volume, will be equal to Mi Hi mass flow rate into He plus heat transfer rate minus of work transfer rate in the control volume. आफ्टर दैट बहुत अच्छा क्वेश्चन आपके सामने ये आ गया कि सर यहां पे ये तो डिसाइड हो चुका है, क्लियर, बट उसके बाद ये मुझे अप्लाई करना है एब्सोल्युटली राइट। और ये क्वेश्चन इस बार गेट में आया था, गेट 22 में। बट इफ heat transfer rate is equal to work transfer rate in the control volume is zero, and this is completely free expansion, that is vacuum. अगर ये vacuum हो and this control volume is equal to vacuum, then you will prove that total internal final energy of this one is equal to enthalpy of this one. तब आप ये प्रूव कर सकते हो कि internal energy of this one will be equal to initial enthalpy of this one will be final internal energy of this one, and final temperature of this control volume will be equal to, if this one is Ti, if this one is Pi, if this one is Vi, like this, then अब मैं लिख सकता हूं कि फाइनल टेम्परेचर विल बी इक्वल टू गामा टाइम ऑफ इनिशियल टेम्परेचर। बट अगेन ये इक्वेशन वैलिड तभी होंगी जब ये इक्वेशन, ये कंडीशन सेटिस्फाई हो, अदरवाइज व्हाट एग्जैक्टली वी विल डू, नहीं तो फिर हम क्या करेंगे सर, नहीं तो हम एज इट इज जो ऊपर इक्वेशन हमने लिख दी है उसको सॉल्व करना होता है। आपको कुछ नहीं करना, उसको सॉल्व करना होता है। लेकिन हम जनरली उस पॉइंट को भूल जाते हैं, एंड मैक्सिमम इंजीनियर्स ने, मैक्सिमम ऑफ इंजीनियर हैव मेड द मिस्टेक इन दिस क्वेश्चन। द सेम ईयर द सेम क्वेश्चन वाज आस्क्ड, बट अगेन इन दैट पार्ट everything was same. It was evacuated chamber, it was vacuum, but this heat transfer was not equal to zero. We generally assume that heat transfer and work transfer is zero in this case, but in the particular question, my dear, heat and work transfer was not equal to zero. So again you have to use this equation, you have to solve this equation, and then you can just write the answer. Great. Okay, correct, good. So in this way, first law of thermodynamics we have completed. Now after that, second law of thermodynamics, available energy, very small topic, thermodynamic relation and pure substance. These topics are left, we are going to discuss these all the topic. If you want break, you can take the break, otherwise we can continue the topic. Can we continue the topic? Okay, yes, write in the comment section. Okay, second law of thermodynamics, sir, what exactly we are getting from the second law of thermodynamics? That transfer of heat from one hot body to the cold body, it is possible. Transfer of heat from one high temperature body to the second high temperature body, it is possible, but reverse is not possible without any supplying of input. And with the concept of this, it was clearly mentioned that first law of thermodynamics only define energy can be conserved. Energy can be, okay, continue. Yeah, this level of energy I want. According to Suvan, sir, continue the lecture. According to Raj, sir, continue the lecture. There are 2 or 3 people who are just asking for the break. Otherwise, maximum of you are waiting for the next thing. Okay, good. Okay, in the starting of any subject, and you are going to have approximate 9 to 10 months for GATE 23 exam. In the starting, it looked like very difficult, very tough. Reason? This duration of the 9 months is very difficult for you. There will be a number of disturbance. There will be a number of members come in your life. But when you will just follow each and every step, Very small step. You can't, simple statement you have listened the number of time. If you can't run, at least walk. So when a small step you will just put, and you will move forward with these small steps, then you will feel each and every topic, each and every question will be very good for all of you. Okay, sir, make your presence in the comment section so that I'll get the idea that we can start the second important point, my dear. That is the second law of thermodynamics. Yes, please write the answer. Write in the comment section. Make your presence in the comment section, my dear. Second law of thermodynamics is known as directional law. Good. All of you. Rajnayak, everyone. Second law of thermodynamics is known as directional law. Sir. Now, before starting the topic, let me discuss what is the source, what is the sink. So, if I'll talk about the source and sink or thermal reservoir, then thermal reservoir. Then there are very few important property related to this thermal reservoir. वो क्या होना चाहिए? Heat capacity बहुत high होनी चाहिए. Because when you transfer the heat, temperature should not change. It means heat capacity must be very, very, very high. No change of temperature during the heat supply. Yes, source can supply the heat without change of temperature. Example, sun. If sun supply the heat to you or atmosphere, temperature will not change. Large, very large furnace are the example of source. Sink can absorb the heat without change of temperature, my dear. Example, atmosphere. Even a large capacity of pond, it also be the example. If you are rejecting a very little amount of heat and capacity of that water is very high, pond is very high, and in that condition you can also say that yes, this point is also the example of sink. Okay. After that, let's try to discuss each and every point or each and every statement and application of these concepts, my dear. Kelvin Planck statement: it is impossible to design a machine which can convert the heat into the work with the help of a single reservoir. Not possible. And this machine is known as PMM2. But again, story does not end here. The same thing was applied for the heat engine. So if I'll talk about the efficiency of heat engine, then efficiency of heat engine, that is 1, my dear. If I'll talk about this heat engine, I can write that efficiency of this heat engine will be equal to 1 minus Q2 divided by Q1, my dear. Similarly, N2 will be equal to 1 minus T2 divided by T1, my dear. So when you will write 1, this is only valid for reversible. This is valid for reversible and irreversible process. Sorry, cycle, not process. Irreversible cycle, my dear. But this one is valid only for reversible cycle. So when you will write the efficiency formula in the term of temperature, so that is valid only for reversible cycle. Okay. So after that, if at any time, let me give you 3 important conditions. If efficiency of first one is less than efficiency of second one, means first efficiency calculating by heat formula is less than efficiency calculating by temperature formula, then definitely it's a right statement. This is the example of irreversible or actual reversible cycle. At the same time, if the efficiency of second one and efficiency of first one both are same, means efficiency calculated by temperature formula and efficiency calculated by heat formula, if these both value are same, we are dealing with, can you write the answer? We are dealing with reversible cycle. But at any time, if the efficiency of first one is greater than efficiency of second one, what will be the answer according to you? अगर एक की एफिशिएंसी दूसरे से ज्यादा हो जाए, मतलब दिस इज द फर्स्ट वन माय डियर एंड दिस वन इज द सेकंड वन. इफ द एफिशिएंसी ऑफ फर्स्ट वन दैट इज कैलकुलेटेड फॉर एक्चुअल साइकिल, if it is more than the efficiency of second one, this is impossible. This is impossible. Correct? This cycle is not possible. Someone has written, Shubham has written, sir, this is the example of irreversible or impossible cycle. Yes, absolutely right. Heat engine, we have solved. Let me discuss next one. Clausius statement and application. It is impossible to reject the heat from lower temperature body to higher temperature body without any input. So again, it is the Clausius statement. If I'll talk about the application, nothing but refrigerator. So if I'll talk about the refrigerating effect in this case, what is the refrigerating effect? To reject the heat from lower temperature body, that is Q2, my dear. So if I'll write the COP of refrigerator, that is first, it will be equal to Q2 divided by Q1 minus of Q2. Sir, valid for, can you write valid for reversible and irreversible both cycle? Very good. This is the first COP of the system. At the same time, if I'll ask COP in the term of temperature, that is T2 divided by T1 minus of T2, that will be valid only for reversible cycle, my dear. That will be valid only for reversible cycle. Then again, if I'll write the COP of first one is less than COP of second one, is it the example of actual or irreversible cycle? Very good. If the COP of first one, my dear, is exactly equal to COP of second one, what is this? Exactly example of reversible cycle. At the same time, if I'll check COP of first one is greater than COP of second one, is it possible? Never, never, never possible, you all mechanical engineer. Impossible. Impossible. So when it is the actual system given to me, what exactly I'll use? I'll use only the heat formula. When ideal or reversible cycle is given to me, I'll use temperature formula, and after that I'll make this relationship between both, my dear. Great. Good. Refrigerator we have discussed. Sir, heat pump you need to do. It's a homework task for you. Try it at home. इसको घर पे करना. अब तब देखना कि आप सही में एज इट इज मिला पा रहे हो कि नहीं मिला पा रहे हो. सीओपी व्हेन हीट से कैलकुलेट किया जाएगा, देन व्हाट विल बी द आंसर. सीओपी व्हेन वर्क से कैलकुलेट किया जाएगा, व्हाट विल बी द आंसर. एंड व्हेन यू विल कैलकुलेट द वैल्यू ऑफ सीओपी विद द हेल्प ऑफ टेम्परेचर, व्हाट विल बी दैट आंसर. This is the homework. I hope you all will solve at home. Okay. After that, the heat pump. Yes. If the refrigerator, heat pump and heat engine, they all are working with same temperature limit, then what will be the answer? Answer at that time will be equal to COP of heat pump. It will be COP of refrigerator plus of 1, my dear, and that will be a reciprocal of efficiency of heat engine. This is the very important relation between COP of heat pump, COP of refrigerator, and efficiency of heat engine when they are working between the same temperature limit. This is the very important relation for all of you. Great. After that, Clausius inequality law. Sir, again till now we all are going to discuss the second law of thermodynamics for a reversible cycle only. Second law of a thermodynamic for a reversible process only. Great. We all are going to discuss second law of thermodynamic for reversible process, my dear. Great. Can I write? For a reversible cycle, according to Clausius inequality law, cyclic integral of del Q by T is 0. It is nothing but it is the example of reversible cycle. Reversible cycle, my dear. Yes, absolutely right. At the same time, if the cyclic integral of del Q by T is less than 0, it is the example of irreversible process. Irreversible, sorry, not process. It must be a cycle. It must be a cycle. And if del Q by T is exactly greater than 0, it is not possible. It is impossible. So what is the meaning of this? This is going to define you. This is going to tell you. This is going to give you an idea that which thermodynamic cycle will be possible, which is impossible, which is practical, which is reversible, which is irreversible cycle. ये आपको ये आइडिया देके जा रहा है. Okay, ये Clausius inequality law, it is very helpful, or it will be very helpful to solve the problem. Can any one of you write? ये कब आपकी हेल्प करेगा? क्लॉसियस इनइक्वालिटी लॉ. न्यूमेरिकल पे आ जाओ थोड़ा सा और न्यूमेरिकल देख के बताओ न्यूमेरिकल टाइम में कब आपकी हेल्प करेगा क्लॉसियस इनइक्वालिटी लॉ टू सॉल्व द प्रॉब्लम ऑफ रिजर्वायर more than 2. When you have number of reservoir, and exactly at that time, my dear, you have to apply the concept of, or you have to solve the problem of heat engine or refrigerator or any component. Then उस टाइम पे आप बहुत बड़ी प्रॉब्लम में आ जाओगे. तो you will apply the Clausius inequality law, any formula as per the given data, और इन तीनों में से जो भी कंडीशन दी होगी आप अप्लाई करोगे. Each and every problem you can solve. इस लास्ट लाइन को बहुत इंपॉर्टेंटली लिख लेना. इट इज वेरी हेल्पफुल टू सॉल्व एनी प्रॉब्लम ऑफ नंबर ऑफ रिजर्वायर व्हेन यू विल हैव मोर देन 2 रिजर्वायर, माय डियर. यस, वन मोर पॉइंट. Let me make one more star point for you. Cyclic integral of del Q by T will give you the idea of the cycle reversible, irreversible or actual. But sir, cyclic integral of del Q only, if it is greater than 0, so it will give you the idea of heat engine, my dear. ये आपको आइडिया देगा कि heat engine है. But again, if cyclic integral of del Q is lower than 0, 0 से कम होगा, तो ये आपको आइडिया देगा is it the example of heat pump or it is the example of refrigerator, my dear. Refrigerator. After that it will be total heat will be equal to 0. It is just a heat transfer. ना heat engine है ना refrigerator है, total heat transfer है, बस सिर्फ heat transfer होगी. If cyclic integral of del Q by T is equal to 0, that is nothing but it is just a heat exchange. हीट का एक्सचेंज है बिटवीन टू बॉडी माय डियर. किन्हीं दो बॉडी में हीट का सिर्फ आप एक्सचेंज कर रहे हो तो ये आपका डेल क्यू या एल्जेब्रिक समेशन, टोटल समेशन आपका 0 आता है. ओके, ग्रेट. नाउ सर वेरी कंफ्यूजिंग और बहुत ज्यादा जो आपका इंपॉर्टेंट मैं कहूं, अगर आप देखने आओ तो मैक्सिमम टाइम ये आपके क्वेश्चन कहीं ना कहीं आपको परेशान करने वाले होंगे. तो एंट्रोपी इज अ वेरी क्रूशियल टॉपिक फॉर ऑल ऑफ यू नंबर ऑफ टाइम. और इसमें बहुत सारे कंफ्यूजन होते हैं कि मतलब कौन सी एंट्रोपी बढ़ेगी, कौन सी कम होगी. नेक्स्ट 5 to 10 मिनट वी आर गोइंग टू डिस्कस, वी आर गोइंग टू राइट ईच एंड एवरी पॉइंट फॉर यू सो दैट आपको एग्जैक्टली एंट्रोपी का एक एक पॉइंट करके समझ आ जाए. पता नहीं चंपक कहां चले गए ऑल, वेयर दीज ऑल चंपक आर देयर. ओके, यस, करेक्ट. एंट्रोपी ऑफ द सिस्टम. आफ्टर दैट फिर से कहेंगे कि कुछ समझ ही नहीं आया एंट्रोपी का. आ जाओ वापस. बहुत इंपॉर्टेंट पॉइंट है क्योंकि इसमें फॉर्मूले, नंबर ऑफ पॉइंट्स इतने ज्यादा हैं कि आप नॉर्मल क्लासेस की बात करने आओ तो यू फील प्रॉब्लम, क्योंकि लेक्चर बहुत लेंथी जाता है और आपके इतने सारे पॉइंट्स मिक्स होते चले जाते हैं कि एट द लास्ट ऑफ द टॉपिक यू फील हमने पढ़ा क्या था, क्या क्या कवर किया है, उन सारी चीजों में प्रॉब्लम आ जाती है. यस, सो लेट्स स्टार्ट द टॉपिक माय डियर. कैन यू शेयर द सेशन. ये पता नहीं चंपक कहां चले गए, कल को फिर से ये रोएंगे नहीं तो. ओके, कैन यू शेयर द सेशन इन ग्रुप. Come back after that. After that, you come back. Let's start the very important topic for all the mechanical engineers, that is entropy. Sir, entropy of the system is nothing but it is the measurement of degree of randomness or disorder of the system. Higher is the randomness, higher is the entropy. Great. Higher will be the randomness, higher will be the entropy. Absolutely right. Good. Great. Absolutely right. Pushpendra, you are very late. बहुत late हो sir. After that, again, don't think that we are going to write each and every step of entropy. No. What formula, what important point are very crucial for us as a topic of entropy. We will connect each and everything, and after that, we will make few star point, my dear sir. If we'll talk about a simple point, Pushpendra, that what is the change of entropy for a reversible process. Just a minute. So can I write entropy change for a reversible process will be written like this. Now after that, sir, you will tell me when heat will be supplied to the system, can I take this value is a plus? Yes. When heat is rejected from the system, this value will be minus, and when heat is not transferring to or from the system, this value will be 0. At the same time, from this one equation, my dear, for reversible process, can I write entropy of system in this case will be positive. Entropy of system in this case will be negative. Very much attention you need to give in this portion, my dear, because there are number of points we are going to discuss. Yes, very much attention. So when heat is supplied to the system, entropy increase. When heat is rejected from the system, entropy of system will decrease. When heat is not supplied or not rejected, then entropy of system will remain constant. Good, very good, all of you. So with this one, and again all the thing whatever we are doing, that is valid for reversible process. So can I write at a star point, these are the number of star. Check. Entropy of the system can be increased, decreased or constant, but in reversible process only. Check this point very carefully. Similarly, entropy of surrounding can be increased, decreased or remain constant. Yes. And all the reversible adiabatic process, when heat transfer was 0, my dear. When heat transfer was 0, it means this is nothing but this was the adiabatic process, my dear. Adiabatic process. Can I write all the reversible, because this is the reversible adiabatic process. So can I write all the reversible adiabatic process are constant entropy process and isentropic process. Isentropic. 3 is star point. Sir, one by one you need to write yes. After that I'll move forward. Sir, first of all, entropy change of all the reversible process regarding the system, regarding the surrounding. How many of you are completely able to understand? Write the answer in comment section. Write down, my dear. Write down the answer in comment section. Yes. Write down the answer in comment section, all of you. If you all are getting, just send me a fire symbol, and after that I am going to start. Yes. Pushpendra, Shubham, everyone. Okay, Raj. Good, sir. Great. After that, let me check what is the entropy of change of irreversible process. Yes. Entropy change of irreversible process will be del Q by T in irreversible process divided by entropy generation, my dear. Here I am more concentrated on entropy generation. Let me write each and every part, each and every point regarding the entropy generation. Sir, this one is a path function. First of all, write down the star point, path function. Entropy generation will be always positive. Reason? Entropy cannot be destroyed, my dear. It will be always positive. And last point, for the reversible process, entropy generation will be 0, my dear. किसी भी रिवर्सिबल प्रोसेस के लिए एंट्रोपी जनरेशन की वैल्यू 0 होगी. यस 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 शुभम, आई विल कम बैक ऑन दैट पर्टिकुलर पार्ट, डोंट वरी. एंट्रोपी जनरेशन for any particular process will be 0. After 10 minutes, you will feel the same point what exactly you are asking right now, Shubham. Okay, great, sir. Now, similarly, I want to check what is the entropy change. What is the entropy change of the system in irreversible process? Sir, you are very much concerned about the entropy change for reversible process of a system already calculated. You are very much concerned about the entropy change of a system in irreversible process. We are going to check. But one thing must be clear to everyone that, sir, this value is positive, my dear. This value is positive. Sir, first of all, you will give me the answer. First of all, you will give me the answer. If heat is supplied to the system, this value will be positive. So in this case, total change of entropy, my dear, if this value is positive, this is also positive. What is total change of entropy? Sir, it will be positive. So when heat is supplied in the irreversible process, entropy will be increase. Great. Great. At the same time, if heat is not supply or rejected from the system, 0, it means this total value, my dear, is 0. What is the value of entropy change of the system? What is the value of entropy change of the system? That is again positive. It means it is irreversible adiabatic process. So what is the meaning of this? What is the meaning of this? In reversible adiabatic process, entropy will never change. But in irreversible adiabatic process, entropy will always increase. Will always increase. Great. After that, let me discuss the last one. If heat of the system is rejected from this thermodynamic system, rejected, minus. So this value, my dear, is minus. This value, my dear, we have already decided plus. 1 plus 1 minus final answer of the change of entropy, that is this final answer of change of entropy, that will depend upon the magnitude, my dear. That may be positive or may be negative, or it may be constant or zero. It may be zero, my dear. It may be zero or zero. So what exactly you are getting? What exactly you are getting? In reversible process, heat will be supplied, entropy will increase. In reversible process, heat will be rejected, entropy will decrease. In reversible process, no heat transfer, change of entropy will be zero. Reversible adiabatic process or isentropic process. Great. But in irreversible process, heat will be supplied to the system, entropy will increase. Heat will be not supplied or rejected from the system, entropy will also increase. Irreversible adiabatic process are not isentropic. And if heat is rejected from the system, it will depend upon the numerical value. It may increase, it may decrease, it may constant, my dear. Are you getting or not? Are you getting or not? Sir, in reversible process, how entropy will increase, I have calculated. In irreversible process, how entropy will increase or decrease, I have calculated. After that, in the same way, let me check what is the change of entropy of universe. If it is the change of entropy, then universe is the example of isolated system. Zero. So in this case, if I'll write, then change of entropy of universe is nothing but it will be equal to ds of generation. So this will be always the positive value, my dear. So what exactly we all are getting in all the real life process, my dear, all the real life process. Yes, absolutely right. Yes, Abhishek. In all the real life process, when entropy of the universe will be always positive, it means entropy of universe can never be decrease. It will always increase. And this law is simply going to signify me that, sir, if the entropy of universe is going to increase, can any one of you give me the answer? What is the effect on effectiveness or efficiency of the universe? That will decrease. It means, according to first law of thermodynamics, we have proved that energy of the universe is not going to change simply related to the quantity. But right now we have discussed, my dear, entropy of universe is increasing, means quantity is not going to change, but quality is going to deteriorate. Is going to decrease day by day. We all are participating to increase the entropy of universe. We all are participating to decrease the quality of energy of universe. So yes, this is the second law of thermodynamics, which will give you the idea that energy or quality of energy is going to degrade day by day. And this concept is known as law of degradation of energy, and that is the reason this prove very important point. Check these all the important point, my dear. Entropy of an isolated system can never decrease. Yes, isolated system means universe. It always increase in all the irreversible process. It remain constant only during the reversible process. But this point you must know, reversible process are just on paper. These are not the actual reversible process. Yes. So this is known as a principle of increasing of entropy, or simple the entropy principle. So second law of thermodynamics is also known as law of degradation of energy, because you are going to prove here that entropy or quality of energy is going to decrease day by day, right or not? So these are all the star points related to entropy, my dear. After that, let me draw for a reversible process. For a simple reversible process, my dear, reversible process, I can write del Q of the system will be equal to T into ds. Or in this case, if I want to calculate the heat transfer in any thermodynamic process, that can be written, my dear, from 1 to 2 T into ds. What is this? What is the meaning of this? That if I draw the TS diagram, or if I draw the any process on TS diagram, and I'll take this area, my dear, this area, this will be nothing but this is the heat transfer. So can I write heat is the area of, my dear, TS diagram about volume axis, entropy axis. So you all will tell me after that, sir, if you want to calculate the total work done, what exactly you need to do? Sir, I calculate the area of PV diagram. If you want to calculate total heat transfer, what exactly we all need to do? We'll calculate area of TS diagram. So my dear, this is proved here that area of TS diagram is heat transfer, area of PV diagram is work done, my dear, work done. So yes, this is the relationship between the heat transfer and entropy. So till now you have defined entropy change of reversible process, entropy change in irreversible process. Right now we have discussed what is the relation between the entropy and heat transfer. After that, let's try to draw the combined first and second law of thermodynamics. Sir, what we have written in the first law of thermodynamics, that del Q we have just written is equal to du plus pdv. Del Q is equal to dh minus bdp, my dear. This was nothing but this was the first law for reversible process only. Reversible process only. Absolutely right. Yes, absolutely right. You all are right. Great. And del Q right now we have proved is equal to TDS, my dear. This one is the second law for reversible process only. Reversible process only, my dear. First law. So in this case, I'll write, if I'll combine both, that combined first and second law of thermodynamics, what can I write? Can you write in the comment section? No. It's a very long derivation. You need not to write. So I'll write this term, my dear. इस term को क्या लिखोगे? This term can be written as TDS is equal to du plus of PdV. Yes, this is combined. Del Q की वैल्यू मैंने TDS लिख दिया. TDS will be also equal to dH minus of BDP. So yes, this is combine first and second law of thermodynamics. Combine first and second law of thermodynamics, जो किसके लिए वैलिड होगा? अच्छा, ये क्वेश्चन है जरूर, किसके लिए वैलिड होगा? That will be valid for a reversible process, that will be valid for a irreversible process. Can you write the answer? It will be valid for reversible or irreversible process. Will it be valid for the reversible or irreversible process, my dear? Yes. Valid for reversible and irreversible process both. It's an example of a property equation, and all the property equation are not going to depend upon process. These are the point function only. Process, my dear. Combine first and second law of thermodynamics. This will be valid for all the reversible and all the irreversible process, because this one is the completely example of property equation, and property will never depend upon the reversible or irreversible. So this will be valid for every process. Either you are going to go with reversible process or you are going to go with irreversible process. Yes, this equation will be valid. Great. Good. After that, how will you recognize area? You will calculate very easy, but how will you recognize that which is the isobaric process and which is the isochoric process? So again the slope will give me the answer, and in this case if I'll check the slope of isobaric process, my dear, that will be equal to T divided by Cp. And if I'll define the slope of isochoric process, that will be equal to C divided by T divided by Cp. Equation 1 and equation 2. Can you tell me from the equation 1 and equation 2, all of you, what is valid for the reversible and what is valid for the irreversible process? Can I write from the equation? One thing is very clear to us, that slope of isochoric process is greater than slope of isobaric process. Angle of the process from horizontal, angle of any process from the horizontal will be a little bit greater than isobaric process. Can you write the answer in comment section? A process is its slope is little bit higher, Raj. Its slope is little bit higher, so it will be a volume constant process, not isobaric. It is isochoric. Raj, check it carefully. And B is isobaric. Slope is lesser, that is isochoric, and with slope is lesser, that is isobaric, and with slope is higher, that is isochoric. Okay, great. First of all, yes, Raju, you need to tell me, till now is everything fine or doubt you are feeling? Sir, in the first line we have proved that what is the change of entropy for reversible process. Second line, what is the change of entropy for irreversible process. Third line, my dear, what is the relation between the TDS diagram and heat transfer. Third point. Fourth point, my dear, what is the combined first and second law of thermodynamics. And fifth point, what is the slope between PV diagram, between isotropic process, isochoric process and isobaric process. These are the 5 points we have discussed till now. Great, absolutely right. Till now we have discussed only these 5 points. Sir, 6 point. How will you check the entropy change of entire universe? Because till now you have defined that entropy of the universe will be greater than 0 in any reversible process. But I know very well that universe is the combination of system and surrounding. But in the system, I can have finite body, I can also have ideal gas. Sir, what is the meaning of finite body? In the system, you may have solid body, example of finite. You may have liquid, example of finite. You may have air, example of ideal gas. But in the source, you may have sink, my dear. You may have source. In case of surrounding. So if you are able to calculate, able to find the formula of this finite body, ideal gas, source and sink, you can easily calculate the value of entropy change of entire universe. Agree or not? If I want to, because till now we have calculated, we have found entropy will increase, will decrease, will be constant, but right now we are going to calculate actual value how the entropy will change, how will you find the entropy change in numerical term. So these are only pure form of numerical setup, my dear, pure form of numerical setup. Okay, yes. So can we start one by one? This one is valid for the solid or liquid. This one is valid for an ideal gas. So first of all, one by one we will try to check entropy change for finite body in this way, entropy change of ideal gas, because at any time in my thermodynamic system, my dear, okay चंदन, अगर किसी भी प्रॉब्लम में थर्मोडायनेमिक सिस्टम में या तो सॉलिड होगा या लिक्विड होगा या गैस होगा, this is the example of a system. Either it is completely filled with the solid, completely filled with the liquid, or completely filled with the ideal gas. So one by one you need to check. When finite body is filled, what is the answer? Ideal gas is filled, what is the answer? So let's try to discuss. Sir, if it is the example of finite body, like this, mass of the finite body this, Cp of the finite body is this, initial temperature is Ti, and it is rejecting the heat like T final. So if I'll write what will be the change of entropy of this finite body, I'll directly write M into Cp into ln T final divided by T initial. I have already calculated these value. You have already calculated or derived these value. But again, here we are going to discuss revision only. So जब जब मुझे finite body दिखेगी, I'll apply this formula, my dear. One part is completed. एक part पहली बार में खत्म हो गया. अब system में ideal gas बची. Yes. In system there is the ideal gas. Sir, when it is a question of ideal gas, then my thermodynamic property may change in this way, like 1 to 2. In any way, it is just an arbitrary diagram I have just drawn. Just arbitrary diagram I have drawn like this. So in this case, when you will calculate the entropy change for an ideal gas, my dear, what exactly we need to write? It will be equal to M Cp ln T2 by T1 minus of Mr ln P2 by P1, my dear. This is the first formula. So with the help of this formula, you can calculate the entropy change of the ideal gas. But point is this, if the final equation is not given in the P1 and P2, T1 and T2, what you will do? You will convert volume into the pressure. Or here, you can also convert the volume into the pressure. And Cv ln T2 by T1 divided by plus Mr ln V2 by V1. You may ask, sir, if it also not given to us, अगर वॉल्यूम भी मुझे नहीं दिया हो तो मैं क्या करूंगा? तो अगेन इसके बाद एक और इक्वेशन है, that is mCv ln P2 by P1 plus mCp ln V2 by V1. So at any time you can use any equation out of this three. तीनों इक्वेशन एक ही हैं. From the ideal gas equation I have converted these all the time. Otherwise all these three equations are the same, my dear. तीनों इक्वेशन सेम है. Okay. So this is the entropy change of gas. End of the story. End of the story. System is over, my dear. So when you want to calculate the entropy change of the system, either it is example of finite body, use the first formula, or it is example of ideal gas, use any of the formula out of these three. तीनों एक ही formula है. हाँ. At which time, at a particular time when a proper property will be given, you will follow that formula. Otherwise, तीनों में एक ही बात है. All the three are same formula. Good. Great. So entropy change of system over, entropy change of surrounding we not to check. Sir, when it will be the case of entropy change of the source, my dear, source T1 that will supply the heat at Q1. So how will you calculate the change of entropy of the source? I know very well in the source when it is the thermal reservoir, then change of entropy will be equal to minus Q1 because heat is rejecting divided by T1. Why you have applied this formula? Reason why you are going to apply this formula? Sir, in the source my temperature is not changing. That's why this del Q by T will be applied as it is. As it is. Similarly, for the sink, if I'll write or if I'll ask the same formula for the sink, that is T2, Q2 is supply. Can you write what will be the entropy change of sink, my dear? All of you. You need not to write, but you need to understand Q2 plus of T2. Plus of T2. Correct. Plus of T2, my dear. So in this case, entropy change of entire universe we have calculated. Because always there will be one system, there will be one surrounding. हमेशा ही एक system होगा और एक surrounding होगी. Then you can check the entropy change of the universe. Then and only then you can check the change of entropy of entire universe. Great. Now, after that, let me solve some few problem. If same heat is transferred from the system, then what is the entropy change of the system? Total entropy change of the entire universe, my dear. Universe. What I'll write? This entropy change, heat is rejecting from the air at a temperature of T1, Q divided by T1, my dear. Plus, this Q is supplied to T2, that is the value of T2. So yes, this one is the entropy change of universe. If heat is rejecting from one particular body to second particular body. If heat is rejecting from one particular body to second particular body, then this will be the total change of entire universe. Total change of entropy of entire universe. Reason, this I will consider a system, this I will consider a surrounding, my dear. Okay, yes, absolutely right. Good. Let me discuss one more important point. Sir, if there will be a mixing, then if I want to calculate the final temperature after removal of this, then I will write that U final will be equal to U1 plus of U2. If you don't mind, can I write by substituting the value of U final, that is equal to MCP delta T, and substituting the value of U1 MCV delta T, U2 MCV delta T, I am getting the final temperature in this equation. Again, in this entire system, my T1 temperature is this one, T2 temperature is this one, and my final temperature is T final, my dear. So this one system is reaching on this one, second finite body is reaching on this one. Are you not feeling that this formula is absolutely fine? Check it. All of you are not feeling this formula, my dear, is absolutely fine to check the change of entropy of universe. How? One is the system, second surrounding. So one is reaching to the final temperature, second is also reaching to the final temperature. So that will be MC ln T final divided by T initial, because it is the example of pure liquid. Liquid is the example of finite body. Apply the concept of finite body. Great. After that, what is the change of entropy? Very good, Sumam. What is the change of entropy of universe? For a cycle. Sir, I have studied that this is the part A, this is the part 2, my dear, this is the heat engine. What is the change of entropy of universe? Can I write entropy change of universe will be equal to change of entropy of system plus change of entropy of first reservoir plus change of entropy of second reservoir. Second reservoir means sink. So in this case, entropy change of the system in a cycle, in the first of the slide we have written, it is 0. Can I write? Entropy change of universe will be equal to change of entropy of source, my dear, plus change of entropy of sink, my dear. System will be not considered in a cycle. If you are able to calculate change of cycle, here we are talking here cycle, change of entropy becomes 0. So in any cycle, if you are able to calculate the change of entropy of a source and sink, you can easily calculate the change of entropy of universe, my dear. Universe you can easily calculate. Great. After that, if you apply the same concept in this case, T1 is the temperature, T2 is the temperature. This is the finite body. Sir, what is the meaning of finite body? That its temperature will start to decrease when heat will be supplied, that will reach at T final temperature, and its temperature will increase like this. So in this case, if I'll ask for maximum work condition, my dear, very important topic we are discussing. Work condition. Can you write what should be the cycle? It's a reversible cycle, my dear. Reversible cycle. Then what should be the change of entropy of universe? That is the change of entropy of source, my dear. Source, this source in a cycle, and change of entropy of sink, my dear. Like this. If this value is 0, then and only then you can say work done will be maximum. So in this case, if you want to check the final body or final temperature, that will be equal to T1 and T2, my dear. Final temperature will be something like this. At the same time, for 3 thermal reservoir, 3 thermal finite body, 3 thermal finite body अगर हैं, 3 thermal finite body है, heat exchange इन तीनों के बीच में हो रहा है, then you need to do the experiment, you need to do the entire derivation, and you need to calculate what is this temperature, my dear. So this final temperature at that time, it will be equal to T1 अगर 3 है तो T2 and T3, and this will be cube root. If it will be 4, fourth root. If it will be fifth root, like this. अगर 3 finite body हैं कुछ इस तरह से. Correct. Minimum work required to transfer to exchange the heat between the finite body. This is maintained at T1 temperature, T2 temperature, and this one is maintained at T1 temperature. If you want to reject the heat from lower temperature, lower temperature, to exchange the heat from lower to higher, let me write. From lower to higher. Then its final temperature after rejecting the heat, it become T final 1, and its temperature become, my dear, T final 2. And again, if it is rejecting the heat now, then yeah, this is the last point I am going to discuss. After that, we will discuss in the part 2. Yes. This one is the refrigerator. This is the W of the refrigerator. Because whenever you will reject the heat from lower temperature body to higher temperature body, then always it will be concern regarding the heat pump or refrigerator. In that condition, for minimum work done, my dear, cycle must be the reversible cycle. And in this case, you can easily write that again change of entropy of source plus change of entropy of sink, it must be equal to 0. And final result when you will get, you need to solve this entire equation. Final result you all will get TF1 is equal to TF2, T1 and T2. This is the derivation we need to calculate for the finite temperature difference for minimum work done, my dear. This result we will get from here if you are rejecting the heat from same temperature, T1 to T2 or T2 to T1, from lower temperature to higher temperature, my dear. From higher to lower you need not to do anything, automatically it will reject. Great. So this is all about the point we have discussed. Yes, what is the entropy change of the closed system? We have already written entropy change of the closed system will be nothing but it is del Q by T, my dear, for irreversible process plus of entropy generation. Someone, I think Shubham, you have just asked this point from the starting. What is the entropy change for or entropy balance for reversible or I'll say closed system? Closed system के लिए entropy balance क्या होगा? Great. At the same time, what will be the entropy balance for open system? Sir, if it will be the control volume, and I'll ask to you that what is the rate of change of entropy in this control volume? So what you will do? Sir, how much amount of entropy it is entering minus how much amount of entropy it is leaving, like this, divided by if any plus any amount of heat is supply, that is del Q by T and plus entropy generation. This is the total value of entropy balance in case of open system, my dear. I think you was asking from the first of the lecture, my dear, if I'm not wrong. Shubham, it was your question now. This is the entropy balance for open system and closed system. Shubham, it is clear? Yes, this is the entropy balance for the open and for closed system, my dear. Yes, absolutely right. After that, if I'll talk about the entropy change of solid, liquid and gas, then one thing is very clear, that in case of solid, my dear, molecule are closely packaged, randomness is very low, after that high, after that very high. So in gas, randomness is very high, so entropy is very high. In solid is little bit lesser. In solid it will be minimum. So if I talk about third law of thermodynamics, the entropy of a perfect crystalline body at absolute 0 Kelvin temperature is 0. That is the third law of thermodynamics, my dear. This one is third law of thermodynamics. And at last, what is the work or what is the entropy associated with the work done? So let me clear. Whenever mechanical work is done on the system, then all the molecule will move in the same manner. All the molecule will move in the same manner. So the change of entropy during any work done, my dear, during any work done, it will be 0. It will be 0. Change of entropy for any mechanical work done time, it will be 0. So this is all about the entropy, my dear. We have discussed all the entropy point we have discussed. So till now we are going to stop the session here. After second half part we will discuss later. But first of all, you write in the comment section whatever we have discussed. Is everything you have written or not, my dear? After that we will discuss in next lecture. Is everything clear to you? All of you? So each and every point you have written in this PDF form. I'll just take the PDF and I'll share this PDF with you guys, and you just keep this PDF for the future reference. and all the formula, all each and every point I have just covered in this PDF. It is going to be a very helpful for all of you. Yes, I'll plan, don't worry about this. Okay, so thank you all, and I'll share this PDF in my Telegram channel, that is Mechanical by Sonu Chauhan, my dear. You join, I'll share this entire PDF after the lecture. So all of you, there are 3 hours, more than 3 hours, and few of you, thank you, and few of you are already presented from the starting, and right now you are here in the comment section. Thank you all. I hope this session is very helpful for you. और एग्जैक्टली टारगेट वही होना चाहिए कि आपको गेट में टॉप 100 में आना है. दिस इज द टारगेट. रास्ता बहुत लंबा है, लेकिन धीरे धीरे ही सही, लेकिन चलते रहो. 10 फॉर्मूले, 5 फॉर्मूले लिखो, 5 प्रॉब्लम प्रैक्टिस करो. इट इज ओके. रास्ता भले ही लंबा हो, बट कीप कंटिन्यू. अपने रास्ते को धीरे धीरे एक एक कदम करके चलते रहो, आसानी से मंजिल मिल जाएगी. सो थैंक यू ऑल द बेस्ट. सी यू अगेन इन द नेक्स्ट सेशन. Thank you everyone. Bye bye. Okay. Yes. Just like the session, all of you, and share the session. Like जरूर करना सेशन को. Thank you everyone.